It's already 9 o'clock, and I think we will start. Welcome to the first presentation of C11 meeting, and I'm very excited for being here, actually. I'd like to introduce myself first. I am Tayfun Özaltın, and I have been working for RIPE NCC Learning and Development team for more than 1 year right now. In the past, I've worked for both vendor companies and also ISP companies in Turkey, and I was dealing with the roles of support engineer and also design engineer. And today I'm here for two different presentations. The first one will be about basic IPv6, and the second one will be about the security part of IPv6. They are both short tutorials. Actually, they are the shortened versions of our trainings, because we have two full-day courses for each of these trainings. Actually, for each of them we have full-day course. So if you would like to learn more about this, because they are just will be remaining here 1.5 hours, and if you would like to learn more, then we strongly recommend you to join our courses face-to-face, or we also have webinar versions of them, so you can just participate in all of these. And again, thank you for joining, and let's start with basics of IPv6. Here, this is our agenda today for the first 1.5 hours. So up to the lunchtime, you will be together with me, I hope so. And the first part will be about the introduction, why we need IPv6. This I will try to explain it to you. IPv6 address basics will follow, and after that part we will be dealing with how you can get your IPv6 addresses from RIPE NCC. And then we will talk about the protocol basics, addressing plan, IPv6 packets, actually the details of the packets, and deploying IPv6, how you can deploy it in your own networks, what we recommend you. And then we will wrap up the session with some tips. So let's start with the IPv4 part. So what do you feel about IPv4, actually? It is a part of our daily lives, right? So can't we just keep using it? Can't we just use keeping IPv4? Unfortunately not, because as you can see here in this nice chart, I don't think that it's nice, but yeah, let's say it's a nice chart. IANA IPv4 pool was already exhausted in 2011. So more than 12 years now, it is exhausted. The pool is depleted. So they allocated the last /8 to the RARs, to each of the RARs, and they are done. So IANA has no more IPv4 in their pools. What about what is the situation with RIPE NCC? So also for RIPE NCC, we can say that at the end of 2019, we also made our final /22, and with this tweet, we just declared that we are already run out of IPv4. So we cannot use IPv4 anymore. It is obvious, because we need something else to extend or grow internet, right? And now our reality is actually the waiting list. So probably most of you know this already. If you would like to still get a /24 from RIPE NCC, we can still supply it, but from the recycled pools. So some of the LARs may be closing, and then we just say that, okay, the IPs are back, and we are redistributing them to the LARs, but you need to wait for it. And as far as I know right now, you need to wait, for example, I think more than 1 year now. So it is actually the obvious that this is not the good way to do it, to grow our internet, to scale it. So we need something else, and that's why IPv6 is here. So let's start with the basics of IPv6 now, and let's see how huge address space we have in IPv6. So this is actually a good representation of IPv6 address distribution. Here on the left-hand side, on the blue circle, you see the all IPv6 address space we have with IPv6. And just a part of it, actually this is the 1/8 of it, has reserved for IANA to be distributed as the global unicast. And it is, actually it is making now 512/12s to be distributed. And up to now, we have just used the orange circle. So it is just 7/12s up to now. So as you can see, we have huge address space, and we are just actually using 8 of them. One of them is used for other reasons, some miscellaneous reasons, but 7 of them have been used by the RARs, and we still have more than 500 under IANA reserve for global unicast. And this is the distribution of the RAR pools. As you can see, in 2006, Afrinic, APNIC, ARON, LACNIC, and RIPE-NCC also got 1/12. And then in 2019, RIPE-NCC got another /12. In the same year also, ARON got another one in November. And now we are in total having 7/12s with LARs. Sorry, RARs. So this was actually the distribution chart. And this is showing us the distribution hierarchy of IP address distribution. As you can see again, on top we have the row /3. It is under IANA reserve. And out of this /3, IANA makes distributions to the regional internet registries, which is also RIPE-NCC, one of them. And with this they are making distributions with /12s, and then out of these /12s, we are making our distributions to the local internet registries, and the minimum size is /32. And out of this /32, in their turn, LARs make their own distributions to the end users. And you see here a color difference between the end user thing and the allocations above. Because the green fields, the green or greenish rows are representing the allocations. They are not real usages. But the blue or dark blue boxes shows us the real assignments or real usages about the IPv6. And here you can see that we can make assignments like /48 or /56. We are actually showing this because 48 is mostly used for the enterprise companies to be assigned, and 56 is mostly used for the residential customers. So we are showing just 2 of them, but you can make assignments out of LAR pool as much as you can. And also you see another orange box, which is connected directly to the RAR, which is RIPE-NCC, and it is connected with the dashed lines. So what does it mean actually? It is representing the provider independent assignment, which is actually meaning that let's think a scenario that you are an enterprise company and you would like to switch your ISP. So in that case, if you don't have your own resources, own IPv6 addresses, then you need to renumber your routers or change the IP addresses on your routers. But if you don't want this, actually, then you can have your own resources with the PI assignment, but you need to apply for it through a sponsoring LAR. So at the end, the resource will be yours, but the LAR will help you to complete the procedures with RIPE-NCC. So that's how PI address assignment works. And it is the minimum size is also, again, the /48. And it is also an assignment, real usage means. So let's check the other details of IPv6 address basics. In IPv6 address, we have 128 bits, which is actually 4 times bigger than the IPv4 address space. And every subnet should be a /64. It is coming from the auto address configuration feature. So every subnet should be given at least a /64. What about the customer assignments? As we said, you can use actually a /64. This is the minimum size. because it is representing one subnet in IPv6. So what about the enterprises, for example, large networks? You can give /48 as well, and it represents more than 65,000 subnets in a single /48. The minimum allocation size for the LIRs from RIPE NCC is /32, and in a single /32 we have more than 65,000 /48s, which you can give to the enterprise companies, or we also have more than 16 million /56, which you can give to the residential customers in best practices. So that is the address space, and this is the distribution plan we have. Let's check the address notation of IPv6. So this is representing actually the full notation of IPv6. This is in hexadecimal, and as you can see, they are separated by the colon signs. So for each part that is separated with the colon sign, we call them as quads or words. So each word will be representing 16 bits in binary domain. So each of the digits here you see is representing 4 bits. So in total, it makes up to the 128. And we have some rules to make it shorter while we are writing these IPv6 addresses. So for example, let's check the first rule. Here, as you can see, you can omit or skip the leading zeros. But please pay attention, you can never skip the trailing zeros. So as you can see, 0db8 becomes db8, but C100 will never become C1. So it is obvious. This is the first rule. And the second rule here we have is the double colon sign that we use. So if you have chain of zeros, then you can represent them with double colon sign. And another side rule for this, you can only use this rule for once for each IPv6 address. So this is the shorter representation of IPv6. And when we check the binary representation, this is actually converted to the binary. So as you can see here, E can be represented as 1110, and F can be represented as 1111, and the others are accordingly. So this is how we write the IPv6 addresses. And let's continue with another topic, actually, with IPv6 subnetting. This may become somehow challenging for you, but if you are getting used to it, then it will be easier. So first of all, we need to split, in order to have subnets on IPv6, we need to split the IPv6 address into 2 parts. The first part is the network prefix, and the second part, 64 bits, will be representing the interface ID. So the interface ID part will never be touched, actually, while you are dealing with the subnetting part, because for this part, this will be used by the hosts to configure their own IPv6 addresses. So we will be dealing with the first 64 bits, and since this subnet is given to us with /32, the first 32 bits also fixed. So the only field that we will play while we are dealing with subnetting with IPv6 is the orange part. So the orange bits are representing our subnetting part. And if you would like to, for example, have some subnets with the size of /64, you need to find the 64th bit here. And it is the last bit of the orange part. And if you just start to increase the last digit one by one, then you will have your subnets, which is actually nicely increasing one by one, and you will have /64 subnets out of this /32 prefix. So it is easy. And also you can have subnets like /60, /56, /52, or /48. Here there is a rule, actually, not a rule but a recommendation, let's say. We always recommend you to have subnets actually on the 4-bit boundary. What does it mean? So we always recommend you to have subnets with the sizes which can be divided into 4 nicely, without any remainder. So if possible, please try to stick to that rule and try to use it, because it will make your life easier. your subnets will follow each other nicely, one by one increasing, and it will be easier for you. You can also have subnets like /53 or /61, /55. They are all valid subnets. You can do it, but it will be harder to follow those subnets. So that's why we recommend the 4 bits boundary rule. Now, with the next slide, I would like to check the multiple address types in IPv6. Let's continue with this one. So we have some different address types here. The first one is unspecified, which is represented as :/128, and the scope is not available here. So it is a different, actually, it is a somehow a different address, and it is just used for initialization of the connection. So the hosts which are using the IPv6 will be dealing with this unspecified range or unspecified address while they are initializing their connection. So they will send the message to the other hosts on the same link with this address on the source address field. So that's why we use it. The loopback is really similar to the local host in IPv4. If you are familiar with it, it is 27.0.0.1 in IPv4, and it is actually the same in IPv6 while we are using loopback. So it is represented as ::1, and it has only the scope of host, which means that actually that address is only valid on the same host. IPv4 embedded addresses are used for the transition mechanisms in order to translate some IPv6 address to IPv4 or vice versa, or for the discard-only addresses are used for the black hole routing and black hole filtering. And they are special subnets actually, prefixes. And the link local addresses are very important in IPv6. They have, as you can see, the scope as the link because they are only valid on the same link. So they are all starting with FE80 : /10. So it means that the first 10 bits are fixed. So for each of the link local addresses, you will see this pattern, and they are used on the same link to get into communication with the other hosts. For the global unicast addresses, you already may be familiar with this one, and we have already seen this in the previous slides. It is under IANA reserve, and it is 2000:3, and it has the global scope, so it is actually reachable from everywhere if you don't filter it. And for the unique local addresses, we can say it is similar to the private IPv4 addresses, which are defined in RFC 1918. So just like the 10.000 network, as you are familiar with IPv4. So they are used in the same reasons, but they should be used in closed networks as well, and they should never be routed to the internet. So it should be used in closed networks, but they also have the global scope. What about the multicast addresses? Multicast has a very important role in IPv6 actually, because we don't have any broadcast addresses in IPv6. So I will repeat this later again, but just to keep in mind, we don't have any broadcast in IPv6. So we do it with the multicast addresses, and they are all starting with FF00::8, and they have variable scope because the bits following FF part will be actually defining the scope of multicast addresses. And let's check the scope a little bit further with this slide. So here you see a simple network topology, simple network diagram. And for example, if we have the interface scope, that address will be only valid on that interface. If you have, for example, link scope, that address will be valid on the link scope. So it will be only valid on that link, and it cannot go further. If you have site scope, which we define the site, then that address will be valid on the site. And as the last example, we have the global scope. Let's check some examples with these scopes. For example, we have FE80 addresses, which is actually link local addresses. So it means that they are only valid on the same link. What about the address with FD00? It is ULA addresses, unique local addresses actually, and they also have the link local scope. What about FF01? It is actually a little bit tricky because we said that multicast addresses has variable scope in IPv6. So the digits following FF part will be defining the scope for multicast addresses. For example, here we have FF01. It means that 01 field means that that address is only valid on the same host. So FF05 is another multicast actually, and it has the site scope. What about FF02? 02 means actually, it is again another multicast, and 02 means link local scope. What about the 2001? I think it is easy to guess. It should have the global scope. So that's it for the basics of IPv6 part, and now we will continue with the getting it part. How you can get your IPv6 address allocation from RIPE NCC as being an LAR or end customer. So how you can get an IPv6 allocation? There are two easy rules to follow actually. To qualify, your organization must be an LAR, and you should have some plans for making assignments within 2 years. So maybe you have some tests requirements, or you would like to test the IPv6 in your own network, in your lab environment. So you should have some plans. So it is really easy to get it. Believe me, trust me. So minimum allocation size is /32 and up to /29. Without any additional justification, you can get your IPv6 addresses. So you can request up to /29. And if you need more, for example, according to your geographical or the security needs, or maybe hierarchical network topology, then if you can justify them, you can even get more IPv6 addresses. And what about the customer assignments? You need to give your customers enough addresses, right? The minimum size, as we said, is /64 because it is representing only one subnet in IPv6. So in IPv6, we don't actually count the host numbers because it is irrelevant. It is not important anymore because we just give 1/64 for each subnet, and it is more than enough for all hosts on the same link. So the host number will not be important from now on. And we recommend you for the future needs as well. You need to at least give, for the residential customers, you need to at least give /56, and for the enterprise, you need to give /48, and up to 48 you can do it. Originally, for more than /48, you needed to send a request form to RIPE NCC to assign more, but this is changed actually. In the past, this was changed, and in 2019 it was changed, and LARs can create assignments larger than /48 without a request. But in that case, if you need more IPv6 addresses, you need to justify them. So if you come to us, come to RIPE NCC and say that, okay, I have assigned more than /48, and now my pool is exhausted, so you need to justify why you assigned /48. Or in a case of audit, it's the same, you need to justify it. So every assignment must be registered in the RIPE database. It is also an important note here on this slide. So it is really an obligation coming from the policy itself. What about the status comparison with IPv4 and IPv6? If you are familiar with RIPE database for IPv4 part, you will be actually knowing all of these IPv4 status, which is actually starting with the allocated PA for the allocations. And allocated PA is equivalent of allocated by RAR in IPv6, in RIPE database. What about the assignments? For assignments in IPv4, we have only one status. It is assigned PA, but in IPv6, we have two different status, which is actually assigned and aggregated by LAR. I will explain the difference a little bit later. What about the sub-allocations? We have for IPv4, we have the sub-allocated PA, and IPv6 allocated by LAR. And for the PI assignments, this is the only field that remains same with IPv6. It is assigned PI and assigned PI and IPv6 as well. Let's check the details a little bit further with some examples. Here we have, for the assigned in IPv6, you need to have one single network or an individual customer or your own infrastructure. So it is used for this reason, and you need to assign it to a single network. How it looks like actually when you check it, we have the allocated by RAR status on top. So it means that actually the pool or allocation assigned to you, or not assigned, allocated to you from RIPE NCC, and you are making assignments out of it. And the minimum assignment sizes, as we have seen before earlier, it is /64. And this is the object, actually how it looks like in RIPE database. So as you can see, we have the INET6 num, which is actually representing the IPv6 objects in RIPE database, and the status is assigned here. So it is really easy, it is really straightforward. What about the aggregated by LAR? I said that I will explain the difference to you, and this is the time for it. So this is used for grouping some group of customers with the same assignment size. Please pay attention to this because this is really important. You need to have a group of customers, and you need to have, for all of them, you need to have the same assignment size. For example, here we represent with /56. So it can be, for example, a residential broadband customer. Let's think that you are an ISP and you are making assignments to your customers, to your residential customers. So in that case, you need to, let's say that you have thousands of customers. And in that case, you need to register all of them in the RIPE database. This is the obligation from the policy, but it is not an easy task, right? So thousands of customers. And with the same assignment size, if they all have the same assignment size, then you can do it in just one go with the status of aggregated by LAR. So this is why we use actually the aggregated by LAR status. And this is actually how it looks like in the RIPE database. We have again the INET6 num, which is 2002001, and DB8, it goes on like this, and it is the size of /36. And we can see that status is aggregated by LAR, and the assignment size for all of them is /56. There's a little nuance here. You need to add this assignment size property to the database manually. It's not coming by default. So while registering this kind of subnet or pool, you need to add this property to the database manually. It is easy. So you just click on the plus button next to the item, and you can just add the assignment size. So let's continue with another status allocated by LAR. Actually, this status can be used for two different reasons, actually. The first one is the reservation, and the second one is delegation. Let's start with the reservation now. So let's consider that you have a large customer which you expect they will be growing in the future. So you can just have some reservation for them. For example, a /46, you can make a reservation for them, and you can just register it in the RIPE database with the allocated by LAR status. And out of this /46, you can have assignments with /48. So you will be reserving some space for this big customer according to the needs in the future. So in the future, if they request more, you can give consecutive addresses to make them also able to shorten their routing tables. What about the second reason of it? The branch offers for the branch offices or departments, we use it as the delegation reason. So it means that actually, let's say you have again a /36 and you are a big company, for example, a bank, then you have many branch offices and you would like to have all the branch offices to have their own /48s and to manage them, to register them in the RIPE database. So you just register /36 in the RIPE database with the same status allocated by LAR, and you give the permission to the branch offices to make assignments out of this /36. So this is why actually what we use the allocated by LAR status in RIPE database. And this is actually how it looks like when you check in hierarchy. It is allocated by RAR, allocated by LAR, and out of this allocated by LAR, because it is allocation, not an assignment, so out of this allocated by LAR status, you will have assigned status. And in RIPE database, you will see this object like this one. So it is really easy. You will have the INET 6num again with /44 and with its status of allocated by LAR, and there will be two maintainers. Maintainers are the protectors of those objects in RIPE database, so it means that they are LUKS, actually. So you have two different maintainers here. One of them is yours, LAR maintainer, and one of them, which is actually maintain lower, will be belonging to the branch offices. So they will use this to unlock this object and to have some assignments to their offices. And this is the overview of what we have seen up to now regarding to the status in RIPE database. So, for example, we have allocated by RAR status, which is actually allocated to the LAR by RIPE NCC, and we have assigned status. We have aggregated by LAR status, which is represented here with /36, and we have also some allocated by LAR status. And please pay attention, there is another link also to allocated by LAR status, which is assigned. So it is important to notice that allocated by LAR is actually an allocation, not an assignment. So out of this, you will make, again, assignments, and you need to register them as well. What about the PI address space? We talked about this in the previous slides, but I would like to repeat it once again. So you can use it to have your own resources without being an LAR. To qualify, your organization must meet the contractual requirements. We have a set of rules for that. And then, if you are an LAR, you need to demonstrate some special routing requirements in order to be eligible to get some PI address space from RIPE NCC. And the minimum assignment size is again a /48, and PI space cannot be used for sub-assignments. And let's continue with some IPv6 protocol basics. Sorry. So, with IPv6 protocol, we have two different features that I would like to mention here. One of them is address auto-configuration, which is very useful to address the hosts, actually. And the other one is neighbor discovery protocol, and we will come to the details of this later. For the address auto-configuration, we can say that it is supported by neighbor discovery protocol, and it has two flavors, actually. The first one is stateless with SLAC, which is actually standing for stateless address auto-configuration. And the stateful version is supported by DHCP v6. And the neighbor discovery protocol has many different roles in IPv6, actually. First of all, it replaces ARP. So if you are familiar with ARP protocol, address resolution protocol in IPv4, it was using the broadcast messages to have the link layer addresses of the IP addresses in IPv4, and neighbor discovery protocol in IPv6 is replacing this protocol. And it uses ICMP v6 and multicast, and it finds the other IPv6 devices on the link as well. So it keeps a neighbor cache for IPv6 devices, and it also keeps the track of reachability of them. So it is really an integral part of IPv6, we can say. For the auto-configuration process, we have 4 different steps. It is starting with making a link local address first, and then checking for duplicates on the link, and search for a router, and as the 4th one, make a global unicast address out of the information that you get from the router. And let's start with the first step, making a link local address. So if you would like to have your link local address as the first step, you need to use your MAC address in IPv6. So what we do, actually, we get FE80 colon part as the prefix that we use. So it is shown here as the blue part of the address. And then you add the interface ID to this. So how you configure the interface ID? You use your MAC address and you split it into two. Just in the middle, you split it, and you put FFFE in between. And then you flip this 7th bit. It is part of the process. If the 7th bit of the MAC address is 0, you flip it to 1, or if it is 1 to 0, and then you are done. So it means that you have the interface ID, and you add this to your prefix, which is FE80 for all link local addresses, and you have your link local address. And after that part, we have the part for checking for duplicates, which is actually called the duplicate address detection. So you use, again, here the neighbor discovery protocol, and you send the message with neighbor solicitation packet. So it is one of the messages that the NDP uses, actually, neighbor solicitation, and it says, hello, is this IPv6 address in use, it says. And if there is someone who is actually using this, then it will reply back with the MAC address. And the host, here in our case, it is host A, will be replacing its IPv6 address with something else. But if it is not in use, then it's good to go. You can use this link local address that you have just created. And how you send this message, actually, the neighbor solicitation message. So you need, as we said, there is no broadcast in IPv6, and we use multicast instead of it. So we use this solo-sited node multicast address in order to make this process efficient in IPv6. So for broadcast, as you can imagine, we are disturbing each host on the link, but we don't want this in IPv6. So we use solo-sited node multicast address in order to achieve an efficiency on IPv6. How we create actually the solo-sited node multicast address? We just get the lower 24 bits of each unicast IPv6 address, and then we add this into actually next to the known prefix, which is actually represented here, FF02 : which means 0, 1 : FF. So actually we have 104 bits fixed, and then we have the 24 bits of the lower 24 bits of our IPv6 address, and we have the solo-sited node multicast address. Actually, in ideal conditions, if you send this message to the link local or on the link, you will be disturbing, or you will be reaching only one host, because it is a really rare case that two of the hosts will be using the same lower 24 bits on the same link. So this is actually how we provide the efficiency in IPv6 with multicast addresses. So each host will need to listen its own solo-sited node multicast address in order to receive message to those multicast group. And for the solo-sited node multicast address, it continues here. So we created the solo-sited node multicast address, and we are sending the message to this address. So we say, hey, this message is for this address, and if there's someone actually listening to this, so it means that it is also using the same lower 24 bits in their IPv6 address, it will reply back with some neighbor advertisement message. So this is how it works. So you will not be disturbing actually these hosts over here. So these hosts will not be disturbed because they are not listening to the same solo-sited node multicast address. So the only host will be disturbed is the related one. So this is how we provide the efficiency in IPv6. And also we use the same thing for the ARP, replacing ARP. So in order to learn the link layer addresses, so it means that the MAC addresses for Ethernet, we use the same process. So we use the same address, same solo-sited node multicast address, and it is also efficient because of this. So let's continue with the searching for routers. So this is the third step actually. So we achieved the, so we are going on with the configuration of addresses, auto configuration. And here we have the third step, searching for routers. With this, with the link local address we start to search for the routers on the link. So we send the router solicitation message to the link, and we say, hello, is there a router out there? And if there is a router, it will reply back with the router advertisement actually. Hello, I'm a router and I have some more information for you. And the router will send you many information in IPv6. So what are the messages, what are the details that the router sent to you? First of all, the router's address, which is very important actually, because this will be your default gateway. So the router address will be your default gateway, and you will learn it through the router advertisement message in IPv6. So if you can remember, or as you can remember, we were delivering the default gateway with DHCP in IPv4. But it is not the case anymore in IPv6, so we are using the router advertisements for this reason. And what else we have? 0 or more link prefixes. We may have, maybe we don't have any link prefixes, but in most of the cases we will have some link prefixes to configure our addresses. And we have information about SLAAC and DHCP-v6 if they are allowed. And lastly, but not least, the optional thing, MTU size. Because again, in IPv6, the routers will not do actually the fragmentation, so we need the MTU size. And if the router advertisements includes this, the host will learn it, and actually the packet size will be adjusted accordingly. So this is the details. These are the details that we get from the router advertisement through the neighbor discovery protocol. And what else we have? In IPv6, our interfaces will have multiple addresses. For example, for the unicast addresses, we have link local addresses, we have global unicast addresses, or for the multicast addresses, we have all nodes addresses. Actually, it is for the link scope, we can say that it is similar to the broadcast because you are disturbing each node. So as much as possible, we just avoid using it. And we have solicited node multicast address actually, which we have seen in the earlier slides. And for the routers, we have all routers addresses, which is actually special for the routers. And in order to verify the reachability, so we say that the hosts will be keeping the track of reachability as well. And in order to achieve it, we again use the neighbor discovery protocol. And it is starting with the neighbor solicitation message again. So it is one type of the, out of the 5 messages we have in NDP, neighbor discovery protocol. So it says, hello, are you still out there? And is your MAC address still valid? The host will ask to keep the reachability because it has the cache in its own memory. And the router will reply back if it is still online. Hello, yes, I'm still online, and my MAC address is this. And if the target does not reply, the host, or the host A in our case, will understand that the host is not reachable anymore, and it will delete the record of the host in the cache. So up to now, we have seen 4 different messages. Let's count them. For NDP we have seen neighbor solicitation, neighbor advertisement, router solicitation, and router advertisement. We said that we have 5 different messages in NDP. So actually we have 1 more messages, and it is redirects. And let's explain this here. Redirects, it is also has an important role, but it can be a little bit dangerous if you don't know what you are doing actually. So in the security courses, we always recommend to disable this by default. So we will see this also actually in the second session as well. And redirects work like this. So you are sending a message to your default gateway, and your default gateway knows a better way to the same destination in the same link. So it will redirect you back to the other router, which can be another exit point from your local link. So let's think that you are sending a message to the destination, destination X, and you are sending the message to router A, and router A sends back to you a redirect message, and it says to you, hey, you are trying to reach network X, but I know a better way to exit to network X from our network, from our local link. You can go to router B. So this is how actually the redirects work in NDP. So with the addressing plans, we can continue. And for this one, I have actually a special note here. I would like to read the first sentence of the presenter notes. So addressing plans because your mental health worth it. Actually, this is the motto of this series of slides for the addressing plan, because in IPv6 we will have actually lots of addresses, lots of subnets, and without making addressing plans, actually it will be chaotic for you. So believe me, it will be chaotic, and you need to have addressing plans definitely. So why actually you need to have good addressing plans? The benefits of having addressing plans actually, because the first item is mental health during the implementation. So it worth it. And the easier implementation of security policies. So for example, you may have some DMZ zone or DMZ area in your network, or some data center, for example. Then you can group your devices, and you can just assign them a single /48. And for the security ACLs or security the lists, you can just have a single rule for that /48. The advantage here is we are starting from scratch with IPv6. So we don't have any addresses assigned yet. So you are starting from scratch, and you can adjust it according to your needs. And we have lots of addresses. The conservation part is a little bit less important in IPv6. So you can assign a single /48 for the future needs as well, and you can group them. And for the security policies, you can have a single rule for all of them. And the third item here is the efficient addressing plans are scalable. So it is actually, and more efficient route aggregation. It is also important. So think about that. In IPv6, we have 32 bits, and we have nearly, as far as I remember now, up to 1 million routes in the internet, on the internet. So think about that, how much or how many routing entries we will have in our routing tables with IPv6 as well. So it will be important in the future to have efficient route aggregation on the internet. So it is also having good addressing plan is also important for this reason. And for the IPv6 address management, we can say that your spreadsheet, your Excel sheet, your Google sheet will not scale. It's obvious, because there will be, I will just read the last two items here. In a single /32, which is the minimum size that you will get from RIPE NCC, you will have more than 16 million /56 in a single /32. And for 29, it is more dangerous. You will have more than 134 million /56 in your spreadsheet. So it is obvious that you need to have an IPAM solution. So we strongly recommend you to have a suitable IPAM for your network while dealing with IPv6. The addressing plans, we have some more notes for the addressing plans. This /64, it should be at least /64 for each subnet. The number of hosts in a single /64 is irrelevant because it's a huge number. So it will be irrelevant, it will not be important because your network probably will not have that many hosts in a single link. So /64 will be enough. and the only thing that you will count from now on with IPv6 is the number of subnets you have. And multiple /48s per pop can be used actually. So the separate blocks for infrastructure and customers. And also you need to document address needs for allocation criteria. So if you have any audit from RIPE NCC, you should have some documents, good documents to prove that you need and you need to assign more than /48. And there is also another reminder here. For the loopbacks, you can use a single /64, and out of this /64, you can assign addresses to all the hosts, all the loopbacks actually, on the same site. So this is an exception actually for the 64 rule. And where actually it comes from, the 64 story, actually it is coming from the auto configuration needs we have in IPv6. Every interface ID must be a /64 actually, and it is defined in /RFC 4291. And the other RFCs also follow this one. Actually, the idea behind this actually coming from the 64 bits MAC addresses, but I won't go into the details of this in this short tutorial. So it is actually planned to use the not 64-bit MAC addresses, but still we use the 48-bit addresses. So that's why we use the modified EUI 64 procedure to have our link local addresses with the MAC addresses. So we put, if you can remember, we put the FFFE in between the MAC address in order to have 64 bits. But originally, it was planned to use the 64-bit MAC addresses. But it is not the case now. The only exception actually for this rule, the 64, is the point-to-point links. We recommend you to use a /127 for each site, for a single point-to-point link actually. But we also recommend you to reserve a /64 for each of the point-to-point links. So while you are addressing, you are configuring your router, you will give /127, but you will reserve /64 for it. So that's the recommendation now. For IPv6 packets, we can check the details now. And the header format is different in IPv6, and we will see in the next slide how it is different actually. First of all, it is in fixed length, unlike the IPv4 actually, because in IPv4 we have options fields which are optional, so it was changing the length of the header. And without the options, the IPv4 header is 20 bytes, and in IPv6, with the fixed header length, we have 40 bytes. So it is twice as long as the IPv4 header. And this is the comparison of the IPv6 header versus the IPv4 header. Let's check them one by one here. So we have some gray fields actually, which are kept in IPv6. So for version, in IPv4 we have version 4 of course, and IPv6 we have version 6. And source and destination addresses are also kept, of course, in IPv6 header. And the red fields, we can say that they are actually cancelled or not kept in IPv6, we can say it. And most of them are carried to the optional fields, which are extension headers in IPv6. So most of them are carried to the extension headers. And the bluish or green fields are kept, but the names are a little bit different. So for example, type of service is traffic class now in IPv6. Total length will be payload length. Time to leave will be hop limit, and protocol will be next header. Sorry. And the only field that we have new in IPv6 is flow label, which is actually used for QoS reasons. So if you would like to have some packets to have the same thread along the way to reach the destination, then you can set this flow label and you can say to the routers, hey, these are the series of packets that I would like to send, and these all should have the same thread over the links. And the routers will understand it and will act accordingly. But I can say that not used right now. We don't see much implementation about it. So this is how it looks like, how the IPv6 header looks like. There are optional fields, and they go into the extension headers. So the IPv6 header is the only part that you see in orange here. And for the extension headers, we can say that it is the start of the payload of IPv6. So here, as you can see, payload, IPv6 payloads includes extension headers, actually the optional fields, and the upper layer protocol like PDU, the protocol data unit. And the whole packet will be representing, of course, the IPv6 packet. And what are the how we connect each of these headers, including also the extension headers as well? We daisy chain them with the next header field. So as you can see here in the first row, IPv6 header is the basic header, and there is a note under it. Next header is TCP. So it is connecting to the next header. And if you check the next slides, they are also in similar way. They are created in the similar way. And IPv6 header is connected to the routing header, and the next header field is routing. This is actually one of the extension headers we have. For TCP, and after that we have TCP header, and they are daisy chained like this. So the fragmentation is also important in IPv6. Routers don't fragment packets with IPv6 actually, because it is more efficient to have it in the source node, and the fragmentation is being done only by hosts in the IPv6 domains. And if a packet is too big for the next hop, then there is a ICMP v6 message, which is called packet too big error message, and it should be sent from the router, which is not supporting that size of packet because of the MTU it has for the next link MTU, and the filtering. So the ICMP v6 filtering will be causing problems if you just filter out all of the ICMP v6 packets in IPv6. So it is obvious that you should keep some ICMP v6 functionality in your networks, because it was not actually case in IPv4, so maybe you were just filtering all of them. It may not have such big problems in IPv4 networks, but in IPv6 it is really big problem, especially for the error messages, for the NDP messages. So if you filter out all of the ICMP v6 messages, then probably you will have no connectivity at all. And we are talking about the path MTU here in IPv6. We don't talk about the MTU, just MTU. We talk about the path MTU because we are doing the fragmentation in the first node. Here in our case, in this example, it is host A. And let's check how it happens actually. So host A will try to send a message to host B, and it will try first to send the message with the size of 1500, because the MTU that it sees is 1500. But the router A will receive it, and actually it is not supporting, the next link is not supporting 1500 MTU, and the router A will send a message back to host A, and it will say, this message is too big. And the MTU, the next link MTU is 1480. And the host A will adjust the packet according to this MTU, and it will send it back. But this time the router B will see it, again, a big message, and then it will send back another message too big ICMP v6 packet to host A, and eventually host A will learn the path MTU. And in this case, it is 1460. And at the end, the packet that is being sent will be reaching to host B. And the minimum MTU size is 1280 in IPv6. So you can never configure MTU lower than 1280. Ordering of headers also important in IPv6. We only hop-by-hop header will be processed by every node along the way to the destination, and the routing header needs to be processed by every router. These are exceptions actually, and all the other information actually will be for the destination node, and the fragmentation has to be processed before the others at the destination. It makes sense because you need to put all the pieces together to understand the message first. So you need to process the fragmentation header first at the destination node. And this is how it looks like actually with the extension headers and also the basic header we have. So IPv6 header will start, and this is actually the exact order of the headers. So we said that ordering is important, and your firewalls, your security infrastructure should also follow it. So it will start with IPv6 header, and next to it we will have hop-by-hop options, destination options, routing header, fragment header, authentication header, which is actually part of the IPsec, ESP header, another IPsec header, and destination options, and at last we have upper layer PDU. So did you notice something here? We only have one extension header actually which is appearing twice, which is destination options. And this is the exception for extension header ordering. So for all of them, we can say that they should only appear once in a single IPv6 packet. But destination options may appear twice if you have, there's a condition for it, if you have routing header. So if you are using routing header as well, next to the destination options, then you can send destination options twice in a single IPv6 packet. Actually, this is for the routers to become aware of some fields in destination options. So they will process up to the routing header. And if you would like to send some messages to the routers as well, you put the destination options as well just before the routing header. This is the exception of extension headers. For the broadcast messages, we don't have any broadcast messages in IPv6. So IPv6 has no broadcast, and there is a similar thing actually for the broadcast. FF02::1, and we usually avoid using it actually because it is representing all nodes on the link, on the same link. So it is not an efficient way to communicate. And the disadvantages of broadcasts, probably all of you aware of it, it will wake up all the nodes, it will create broadcast storms, and also only a few devices are involved. So for only few devices, you will disturb all the nodes on the link. So that's why we quit using broadcast messages on the link and in IPv6. This is not an efficient way of doing it. For the neighbor discovery protocol, we can say the functions of it, we can list them again. We actually mentioned some of them earlier. We can use it for address resolution instead of ARP, instead of address resolution protocol in IPv4. We can use it for finding neighbor routers with the router solicitation messages. We can use it to track address changes, for example, to keep the reachability information, and to check again the neighbor reachability with the neighbor solicitation and neighbor advertisement messages. And we can also use it for the duplicate address detection while we are configuring our own IPv6 address. So for example, we configured our link local address first, and the host sent the message to the link to check if there is somebody else which is also using the same address on the same link. And we actually counted the messages in NDP earlier. Do you remember them? Let's count them together. Neighbor solicitation, neighbor advertisement, router solicitation, router advertisement, and the redirect messages. Those are 5 different ICMPv6 messages, and they are used for neighbor discovery protocol. And just before the last part, we have deploying IPv6. This is the 7th section of today, and we will talk about how you can deploy, or what points you need to pay attention while you are deploying IPv6. For assigning addresses, we can say that routers influence how hosts connected to the network. So it is very important. Routers have very important role in IPv6. It may have several options in router advertisement messages. For the assigning addresses we are talking about, there are several options to assign IPv6 addresses actually. The manual configuration, and the router advertisement only with SLAAC, and we may have combinations of them. For example, the router advertisement message plus DHCPv6 with mFlag on. What is mFlag? Actually, mFlag means that you need to use managed way of assigning IPv6 address, and you need to use DHCPv6 in order to get your IPv6 address. So it is indicating, it is just a single bit in router advertisement, and it will tell you that you need to use DHCPv6 in order to get your IPv6 address. You can also use array message with SLAAC plus DHCPv6 with OFLAG. Without mFlag, you can use it OFLAG. OFLAG means other information. So in this case, you will configure your own IPv6 address with SLAAC, and then in order to get more information like DNS information or domain name or FTP information, you will go to the DHCPv6. And this is actually indicating this. There are some flags in router advertisement messages. And also another combination, router advertisement plus DHCPv6 with mFlag on. So in this case, you will not configure your own IPv6 address. So the router advertisement probably will have no prefixes inside. And then you will go directly to the DHCPv6 to get your IPv6 address. And as we said earlier, gateway is always provided by the router advertisement in IPv6. So getting the gateway, default gateway from DHCPv6 is not an option now. For the router advertisement options, what we can say more actually, array messages is used to provide configuration information like default gateway addresses, which prefixes to be used on the link, the prefix length of it. The SLAAC, is SLAAC allowed, is DHCP allowed for only options or getting addresses. The DNS servers, domain names, they are optional in router advertisement actually. We call it RDNSS. And another optional information is MTU size, as we also said earlier. So what else we have more? We have algorithms actually to create our interface IDs. So in order to create your interface IDs, last 64 bits of your address. So the first 64 bits is the network prefix, and the last 64 bits is the interface identifier. And in order to configure the last 64 prefix identifier, I mean the part, you have several options. You have several algorithms. The first one is modified EUI64, which is based on MAC addresses, and this is actually found considered a little bit dangerous on the internet, and because it can be trackable. It is tied to your MAC address, and it can be trackable. So what about the other options? If you would like to have some stable addresses, just like we have in modified EUI64, then you can use a newer algorithm, which is stable semantically opaque addresses. And I will explain this later in the next slide. For the temporary addresses, if you would like to have some addresses to change over time, you can use temporary addresses extensions. It is defined in RFC 8981. And as you can also understand from the name, they are temporary. And if you connect and disconnect and connect again your network cable to the same network, the network address or the IPv6 address will be changing. And also it will be changing without disconnecting it. It will be changing over time. So it is temporary. And most of the operating systems use this for the outgoing connections. Because for the incoming connections, you never want to change your IPv6 address because the source node will need to know your address in order to be able to reach you. For the stable semantically opaque interface IDs, we can say that they are widely used and standardized for stable addresses now with the RFC 8064, and they are considered actually as opaque because they are not related to any fixed interface identifier on the host. They are opaque, semantically opaque we call, and they are stable. So whenever you connect the same interface to the same network, you will always get the same interface ID. So if you just close the lid of your laptop and open it, or just disconnect it to connect it again to the same network, you will get the same interface identifier, the same IPv6 address, as long as the prefix is the same, of course. And what about the DHCP-v6 option? If you would like to configure your IPv6 address through DHCP-v6, you can use it. It's available. You can also use it to get also additional information from DHCP-v6, just like the DNS servers. And the router advertisement will need to have some flags on in order to be able to use DHCP-v6. We can use it, for example, with the M flag on in order to have stateful DHCP-v6 option, or we can use it with the O flag on. We can have the router advertisement message with the O flag on in order to be able to use stateless DHCP-v6. So that is actually how we use DHCP-v6. And let's check them one by one with each scenario. This is the scenario that we see with the M flag on, which means that DHCP-v6 server will give you the IP address. So in this case, if you are familiar with the messages in IPv4 while we are using DHCP, it was DORA, discover, offer, request, and acknowledge, as far as I remember. And the messages here are SAR. So it is solicit, advertise, request, reply. And it is starting with the hosts. The host will send the message solicit to the router. And if you have a relay server as well, then it will be relayed to the actual DHCP-v6 server. And the reply will come back and go back the request. And also, at the end, the server will send you the reply. So the process will be completed. And with this process, the DHCP-v6 server will keep the track of your IPv6 address. So in the memory of the DHCP-v6, it will know that which IPv6 address you are using. So there will be a binding with this option. So it is provided by the router advertisement messages with the M flag. So that's why we have here the M equals 1. So what about the other option? It is DHCP-v6, but this time M flag is 0, but O flag is 1. So in this case, actually, the DHCP-v6 server will not be keeping your IPv6 address because it will not give you the IPv6 address. So there will be no bindings, but in this case, you will only get some more information from DHCP-v6, just like DNS information, the domain name, the FTP server, TFTP server, or whatever you want to configure for your host. And the process is a little bit simpler. So you can say that the information request will go from the host to the server, to the router first, and it will be relayed to the DHCP-v6 server. The DHCP-v6 server will reply back with the reply message, and then it will be again relayed to the hosts. What about the DNS? Is it difficult to have DNS in IPv6? Actually not, because DNS is not IP layer dependent. So DNS will not check your IP address which you are using to reach to the DNS server. So whatever protocol you reach to the DNS server, it will reply back to you what you request. So if you are requesting a record, which is actually for IPv4, it will reply back to you with a record. And if you are requesting quad A, which is AAAA record for IPv6, then it will reply back with the quad A record. So you can do it, for example, in a scenario, think about it, you can reach to the DHCP v6 server with your IPv6 address, and you can request a record for IPv4. It is valid, and it can use it. So it is really easy, it is really straightforward. It doesn't answer based on the incoming protocol. It only checks the message inside the information inside the message. The only challenges for DNS part is the NAT64 or proxies, because we are breaking the communication for DNS connection, and it will be difficult to use DNSSEC if you are using it with the translation. And for the last section, we will talk about some tips for you in this last section. How you can get started. Actually, first of all, you need to change your purchasing or procurement procedure. So you need to, from now on, if you would like to plan using IPv6, which you should do, actually, you need to check the feature parity. So whatever you request for IPv4, you need to request the same for IPv6 as well from now on. And you need to check, of course, your current hardware and software in order to be able to support IPv6 in your network. You need to check the feature parity as well. And you need to plan every step and test them. We strongly recommend you to have a lab environment for IPv6. Probably you have. And we also recommend you to just configure one service at a time. So first of all, maybe you can just have customer-facing services. Then you can have core network. You can have customers, enterprise customers maybe. So plan it and have it. Don't have it in one go. Don't try it. It will be somehow disaster. And in order to be able to prepare your RFPs from now on, you need to have some knowledge about IPv6 requirements, right? So you don't know where to start. And this is actually a good document to start. It is RIPE 772 document, and it is listing actually the requirements for IPv6 in ICT equipment. So for each type of equipment, we have a list of RFCs to be supported in this document. It is actually originated from the Slovenian government, and it is adopted by others as well, like Germany and Sweden. So you can actually use it. It is a very useful document, and you can just prepare your RFPs, request for proposals, with this document. And the link is provided here. I hope that you will get these slides on the site, C11 site. So what about the troubleshooting part of ISP for help desks? Again, we have a document for it, which is actually RIPE 6231. Actually, this is also another good document for the troubleshooting part of the IPv6 networks, because your help desks will need it. Your help desk will need a basic knowledge about IPv6, and they need to have some kind of document to start. It is actually a generic troubleshooting guide, and based on the open source testipv6.com tool, and it is customizable. So you can customize it according to your needs in your network. So you can use this. And what next we have for the customers and their /48, your customers will be confused actually when they get their /48, and you need to also provide them a document to use it properly and to have a good addressing plan. So this is also another document. You can find it also on ripe.net site. Your customers will have actually more than 65,000 subnets. It means one subnet means /64 in IPv6. So more than 65,000 /64s in a single /48. So you need to provide them information because they will not know how to configure, how to use that huge address space they have. And this is the document that you can use for those purposes. Basic IPv6 addressing plan, how to document. And we have some don'ts for you. Don't do this. Don't separate IPv6 features from IPv4. So you need to have feature parity, as we said. Don't do everything in one go. And don't appoint an IPv6 specialist. So do you have an IPv4 specialist here? I don't think so. We all know IPv4. And we need to know IPv6 as well. So just like we know IPv4. And the last one here is to remind you that the internet is the product, IPv6 is not a product, actually. And this is the last slide for this one. And I would like to also give another tip for you. You can get all of this information. You can check our website, academy.ripe.net, in order to have a free course about IPv6 basics, and also we have IPv6 security, BGP security, and also RIPE database courses on this website. So you can just check them. It is free. You can use them. So you can just work on all of these information on this website at your own pace, in your home comfort. So it is easy to use it. And the next one we have is the certifications we have. We put a lot of effort for these certifications, actually, and we got really good feedbacks about it. So we are proud of ourselves. And we have 4 different, actually, RIPE NCC certifications up to now. The IPv6 fundamentals, RIPE database, BGP security, IPv6 security, so you can get them. Actually, they are paid examinations, but since, as you are LIR, you have 3 vouchers per each year, and you can get these certifications, you can get these examinations for free 3 times in each year. So we also strongly recommend you to have these certifications to show your knowledge about all of these topics. If you have any questions, I'm here for them, and this is the end of our slides. That's it. Thank you very much. Do we have any questions regarding to the topics? Or we can also have it, if you don't want to ask it now, you can also have it in the coffee break. So I think we will have coffee break up to 11 o'clock, and in the next session I will try to help you about the IPv6 security part. So, yes, I think we should start. We had a break, and now we are fresh, I believe, again. And welcome again for the second part of this session. It is about IPv6 security, and it will be again a shorter version of our course, a full-day course about IPv6 security. So for the newcomers, maybe I can introduce myself again. I'm Tayfun Upton. I am working in learning and development team of RIPE NCC, and now we will start with the IPv6 security part. This is the overview of our agenda for this short session. Actually, it is short for IPv6 security, I know, but we will try to give you some basics about IPv6, and you will see that in order to be able to have good IPv6 security, actually we need to have a mindset change about IPv6. So this is the overview. We will start with comparing IPv6 security versus IPv4 security. And in the second part, we will talk about the reachability of IPv6 addresses. So we are talking that actually IPv6 addresses are reachable from all over the internet. Is it the case actually? We will see. The network scanning part in IPv6. What about the dangers of, or the threats of IPv6 network scanning? Is it easy or hard? Attacks on IPv6, we will check. We will check some attack types. And we will compare again the IPv6 versus IPv4 in the security manner. And we will check the support for IPv6. IPv6 only networks will be our next topic. We will check how you can secure, or should you actually be concerned about IPv6 security in your IPv4 only network. And as the last part, we will talk about the IPv6 security resources. Do we have enough resources to be able to secure our IPv6 networks? So let's start with the first part. This will be a little bit different than the previous one actually. In the beginning of each section, I will show you some statements. I will show you some statements which seem to be valid for IPv6 security. And then I will explain you what is the reason behind this idea, and then we will check what is the reality now. So let's start with the first one. IPv6 is more secure than IPv4. So normally in the face-to-face courses, I would ask you, do you agree with me? So is this statement is true? But this room is too big to do this actually, and I will reply myself. IPv6 is more secure than IPv4. IPv6 has better security and it is built in. It seems valid actually, but the reason actually behind this statement is an old RFC, 4294, and in that RFC, IPsec was a must actually. But in reality, it is not the case anymore. So there is an updated RFC, it is 8504, and now IPsec is a should, which means that in the RFC language, it means that actually it is an optional thing. So IPsec is still available and used for security in IPv6 protocols as well, just like we use it in IPv4. IPsec is also available for IPv4 as well. So there is no difference in between. So this statement actually arguable, so it doesn't seem true. Actually, we need a change of mindset in our minds. So IPv6 is not more or less secure than IPv4. The knowledge of the protocol is the best security measure. So that's why actually we are here. That's why we deliver courses, because as we learn much about IPv6, our networks will be more secure. Because we will learn about the basics of the protocol, we will learn more about the threats we have in IPv6, we will learn more about the security aspects of it, and we will also learn about the best current practices and the documents that we can get benefit. So for a good level of security actually, we have 4 steps. Best security tool is our knowledge. And the second one is IPv6 security is a moving target, so it is not a static thing. So you cannot just secure the network and leave it there. So you need to follow the best current practices, you need to follow the new threats, you need to follow the new patches, new updates to the firmwares, whatever it is. So it is a moving target and you need to follow it. IPv6 is happening and need to know about IPv6 security. I will show you actually in the next slides. IPv6 is really happening on the world. So we have lots of networks with more than 50% IPv6 availability, and there are also threats on the internet about the IPv6 security. And for the last item, we can say that IPv6 is the future of the internet. So it is about the scalability of our networks. So we are all talking about the IoT things. We are all talking about the 5G, right? The massive connection. And we need IPv6 because of this. So in order to be able to connect all of those devices with the NIV IPs, we definitely need IPv6. This is our NIV protocol, and we need to get used to it. The second statement we have, IPv6 has no NAT, global addresses are used, and I am exposed to attacks from internet. So what do you think about this? Actually, the reason behind this is the end-to-end paradigm we have in IPv6. So in IPv6, we have the end-to-end paradigm back. Actually, IPv4 was also designed to be end-to-end, to have the communication end-to-end. But we broke it with the NAT devices, or CG and LSN devices, or carrier-grade NAT, or large-scale NAT devices. I'm sure that you are all familiar with NAT. So we are translating addresses from one to another. And we are breaking the communication there because we are changing the addresses in the IPv6 IP packets. So in IPv6, we don't have NAT. This is true. So this statement is partially true. Well, we don't have any NAT implementation in IPv6. And global addresses are used. This is also true. But it is not true that you are exposed to attack from internet. Actually, the reality is global addresses does not imply the global reachability. So you are responsible to filter the networks at the, filter the packets at the edge of your networks. And you need to do it actually. A good filtering is a requirement, is a must for IPv6. Because as we said, from now on we don't have NATs, so there is no block on the communication. It is a good thing actually, because NAT was breaking many things, and also NAT has some issues as well, and hidden costs, for example, the logging of everything, and also the troubleshooting expenses, or the knowledge about the NAT. So NAT is not something that we need to stick to. We are doing good actually by quitting NAT, but in the manner of this, or in the aspect of security, we need to secure our networks with the good filtering. So it brings us to the firewalls. And I would like to talk about more about the features of IPv6, what is changing with the IPv6 addressing structure. Actually, the first thing that is changing is the end-to-end paradigm, and we already talked about this, right? The second thing, we have a huge address space, really huge address space in IPv6. Can you read this number over here? Actually, this is the number of IPv6 addresses we have in IPv6 protocol. So it is not, we are not able to read it. I don't believe that. So we have a huge address space, and you need to be careful actually while you are protecting your networks, and you need to think about this. What about the /64 thing? We are not caring about, as we have seen in the first part, we are not caring about the hosts anymore in the network. We are just caring about the subnets, and each subnet should have a /64, and you need to design your networks according to this. The number of hosts are irrelevant. And the last thing I would like to share, the multiple addresses we have in IPv6. So in IPv4, we were dealing just with one address on an interface, but now we are dealing with multiple addresses. For example, the link local address, for example, the global address, or the multicast address. So we have lots of them. And also, you may have more. So you may have, for example, multiple of global addresses. One temporary address, one stable address. For the incoming connections, you use the stable addresses. For outgoing connections, your operating system will use the temporary addresses. So you have lots of them, and when you think about the security, you need to consider all of these. So let's check again the IPv6 address scopes. We have seen this slide actually in the first part as well, but it's good to remember it. So the addresses in IPv6 address structure is defined with the scopes as well in IPv6 world. So for example, for some addresses, we have only the interface scope, which means that actually it is only valid on that interface. Or we have link scope, which addresses are valid on that link. Or the site scope or the global scope we have, and they have many other scopes. So while you are thinking about the security aspects of the IPv6, you need to also consider all of these, because some addresses will not leave or should not leave the link local or the link in your subnet. So this means that if you are seeing some packets with the range of link local addresses, you need to filter them at the edge of the network. So it is something to consider. So we have some examples here. FE80 means the link local addresses. FD00 means the unique local addresses we have. FF01 : 2 is the multicast addresses, and with the interface scope, FF05 is site scope multicast address, and FF02 is another one with the link scope, another multicast address actually, and 2001, the address starting with 2001 actually is another address with the global scope. What kind of addresses we have more in IPv6? Again, while writing your filters on your firewalls, on your devices, on your ACLs, you need to know about the different types of IPv6 addresses or special or reserved addresses. So this is a good list, but it is not actually the whole picture. If you would like to check more, you can go to the IANA site, and in the IANA site, they have a special page, IANA IPv6 Special Registry. So you can check more. But here I would like to check a few of them with you. So we talked about the unspecified address in the first part. So it is just for the initialization of the connection. It is just used for the first packet that you send with the neighbor salt station to the link. The loopback addresses is only valid, should only be valid on the same host. Actually, it is a local host in IPv4. It is the equivalent of it. :1/128. We have some documentation addresses. We have some translation addresses. And for example, for the documentation, we are using it for just document something. Because sometimes maybe you already experienced in your networks while you are testing something or documenting something, you are just writing an arbitrary IPv4 address, and eventually you configure it on the router in the live network by mistake, and then you are having problems. So in order to avoid this, we have a special reserved place for the documentation needs in IPv6. And if you see some packets coming to you with this IPv6 prefix, then you need to filter them as well. And what about the for the documentation, maybe I need to have a note as well, if you are not in a LABA environment, of course. So IPv4 to IPv6 translation, it is 64FF9B:/96. This is a special range, the prefix range, to be used for the translation from 6 to 4. It should also be used on that purpose only. What about the discard-only address blocks? We use them for black hole routing or black hole filtering. It is defined in RFC 6666. Good RFC number, right? So it is the discard block. And for some other transition mechanisms like Teredo or 6 to 4, we have special ranges. So for all of these, I just wanted to mention some of them. For all of these, you need to have the knowledge of how they are used and what is the purpose of them. So in your network, if you see some packets like this, you need to know the reason of it. And if it has no valid reason to be used in your network, then it may be better to protect your network and to just block them. So that's why we are actually showing them to you in the security courses. What about the security tips we have about this? We recommend you to use hard-to-guess interface IDs, which is actually we covered in the first part while we are creating interface IDs, we were talking about the stable semantically opaque addresses. We were talking about the modified EUI64 method, or we were talking about the temporary extensions. So there are all algorithms that we can use for the interface IDs. But also, you can do it manually, for example, or you can do it with the help of DHCP-v6. And in that case, you need to use hard-to-guess IIDs as well. And we recommend you to use the stable semantically opaque addresses rather than modified EUI64 addresses, because modified EUI64 is based on MAC addresses, and it will be easy to guess for the attackers to check your modified EUI64 addresses. And also this RFC, I mean the RFC 72217, which is defining the process for stable semantically opaque addresses, is standardized as the default with RFC 8064. So now we are using these kind of addresses as the default with many of the operating systems. We strongly recommend you again to use IPS and IDS to detect scanning. I know that it requires some investments in your networks, but it will worth it. So you will need it at some place, and it will worth it. Filter packets where appropriate. It is something that we will repeat actually throughout this session. Filtering is really important. Be careful with routing protocols. So if you leak some information to the local network by mistake, the attackers on the same local network may learn about your network prefixes that you use on the core network. So you need to be careful about the routing leaks to the host network. And we recommend you to use the default 64 size for IPv6 subnet prefixes. This is actually a requirement by the RFC as well. The filtering is very important, we said, because we are using the global UniQuest addresses in IPv6, so they are reachable unless you just filter the packets properly at the edge of your networks. So you will definitely need a firewall to filter the packets at the edge of the networks. And if you have, but we have one advantage here, since we are starting from scratch for the addressing plans, we may have a good addressing plan, and we can group some hosts or some devices in our networks so that we will write easy rules for all of them, and we will manage them in a good way. So it will make your lives easier to have good filtering. We have some new filters to take into account, because these items mentioned in this slide are totally new for the IPv6. We don't have them, or we don't have any equivalent of them in IPv4. The first one is ICMPv6, IPv6 extension headers, fragment filtering. This is not new, but the implementation of fragmentation is new in IPv6 because we don't do fragmentation on the routers. And the transition mechanisms or dual stack hosts are also new in IPv6. And let's check them one by one now, these items. So you need to be careful actually while filtering the IPv6. So it is used in many different protocols in IPv6. For example, we use it for NDP. We just counted 5 different messages with ICMPv6 in NDP, and it is used by NDP, ICMPv6, I mean. And it is also used, for example, for the MLD, which is Multicast Listener Discovery Protocol, and it is also part of the IPv6 networks. So it has many different usages. And since we have different usages in ICMPv6, we need to be careful about filtering all of these packets, ICMPv6. You cannot just filter all of the ICMPv6 packets, and as we said earlier, if you do that, actually, you will have no connectivity at all in your networks. So in ICMPv6, we have two different types of messages. One of them is error messages, which is actually with the types destination unreachable, packet too big, time exited, and parameter problems. And we have many different subtypes or codes for it. If you somehow would like to filter some of these messages, you may have good reasons for it. You need to know the codes as well. Because you may, in most of the firewalls, in most of the security infrastructure, you may be able to filter based on the codes of ICMPv6. So you need to also check all of these codes or subtypes. What else we have? Actually, we have a good list for you for the recommendations of the ICMPv6 filtering. So, for example, we say here that type 1, type 2, type 3, and type 4, which are all error messages in IPv6, should be allowed on the firewalls because they are error messages, they are important, and they shouldn't be filtered. What about the type 128 and 129? Most of you should be familiar with these type of messages from IPv4. They are echo request and echo reply messages. So you can allow them for the troubleshooting purposes, but you may have some rate limiting on them. So in order to be on the safe side of security. For the MLD messages, we said that it is also part of the IPv6 networks in the local networks. They are using the types of 131, 32, 33, and 43, actually, and they should be allowed if the multicast packets are going through a firewall. So most of the cases, it is not the case because your local network, MLD works in the local network, and your local network will not have a firewall, or you will have it at the edge of the network, so the MLD messages will be staying inside the network. But if they go through a firewall, they need to be allowed. And we also do the same recommendation for the first 4 types of NDP protocol. What are those? Router solicitation, router advertisement, neighbor solicitation, neighbor advertisements. So if they also go through a firewall in your local network, they should be allowed. What about the 5th message, the redirect message in NDP? As I said earlier in the first session today, we recommend you not to allow it by default. If you are exactly knowing that what you are doing with the redirect messages, you can allow it, of course, because you may need it somehow in your networks. But if you don't know what to do with those messages, then it is better to keep it not allowed or blocked. It is same for the router renumbering. It is for changing the IP addresses of routers on the same network. So it is better to keep it not allowed. And if you would like to check more, you can check the RFC 4890. These recommendations are all coming from that RFC. So what about the extension headers? This was the second item actually in our list, the new items in IPv6 networks. The firewalls should be able to recognize and filter some extension headers. So we have some extension headers which is actually considered as dangerous. For example, RH0, it is routing header 0, and it is actually now deprecated. So it is not used anymore. So your firewall should be able to recognize this specific type of header, extension header, and should be able to block it. And what about the chain of headers? It should follow the chain of headers. It should not just check the first or basic IPv6 header and just allow the packet according to the next header field maybe. It should follow each header one by one until the PDU, maybe upper layer PDU. And it should again not allow forbidden combinations of headers. So we said that, earlier we said that the extension headers has an order. You cannot just mix and match them. And your firewall should be aware of it, and if needed, should be able to just block or deny those packets which are not coming in the correct order with the extension headers. So the next item is about the filtering fragments. So here we have the some attack types or threat types about the fragmentation. So for the upper layer information, not in the first fragment, for example, we can say that it creates many tiny fragments to go through the filtering detection without being detected by the filtering, and it is dangerous. For the fragments inside fragments, so you may have several fragment headers in a single packet to pass through the firewall equipment or the security infrastructure. You may again have fragmentation inside the tunnel. It may have some valid usages, so it may not be an attack as well, but it should be checked. So the external header hides the fragmentation in this case. You will have the tunnel header first, and inside that tunnel header, or after that tunnel header, you will have the fragmentation, and your firewall should be able to detect it. So what kind of countermeasures we have? For the first one, we can say that upper layer information, if the upper layer information is not in the first fragment, it shouldn't be allowed. So all the header chain should be in the first fragment. The second one, fragments inside fragments. This is not also allowed in IPv6. You cannot do tiny fragments inside other fragments packets. So there should only be one fragment header in each packet, and this should be filtered if you see them in your networks. And what about the fragmentation inside the tunnel? Firewall, intrusion prevention system or intrusion detection systems should support the inspection of the encapsulated packets. So the tunnel header will be encapsulating the fragmentation header in our case, and actually this should be inspected by your security equipments. What about filtering the transition mechanisms or the dual stack hosts? Let's start with the dual stack first. If you would like to somehow block or filter native IPv6 traffic, you should check for the ether type. It is 0x86DD. So if you would like to write some rules about it, then you can just write to filter the ether type this, or 0x86DD. If you would like to, for example, block some IPv6 packets inside IPv4 packets, then you need to check for the protocol number. In the IP header, you need to check for the protocol number 41. And as you can see in this table, it has many fields to be used actually. For example, for 6M4 protocol, it's a transition mechanism. 624, 6RD, they are all transition mechanisms, and ISATAP actually uses this protocol number in the IPv4 headers. And if you would like to, for example, block these protocols to be used in your network, then you need to block those protocol numbers, I mean the 41. And for example, the Tevedo uses the UDP destination port 3544. So as we said, the knowledge is the best tool for the security. So since you know all of these numbers and you know all of these protocols, and since you know your network as well, you can just decide which numbers, which filtering rules should be applied, which numbers should be blocked. So again, we are on the same point. The knowledge is the best security tool. And if you would like to check more, you can just check the RFC 7123. And for the IANA protocol numbers, you can also check the protocol numbers page of IANA, if you would like to check other protocols as well. So IPv6 packet filtering actually has some features in IPv6. It is much more important in IPv6. We will repeat this throughout this session actually. And we have common IPv4 practices. For example, we are using the same filters to filter some UDP or TCP ports because they are in layer 4, so nothing different. What about the new concepts in IPv6? We have end-to-end paradigm back. So we talked about this. It needs filtering. ICMPv6 should be wisely filtered because it has many different fields that is being used. And we have filtering adapted to IPv6. For example, we have new concepts like extension headers or transition mechanisms. So they are totally new concepts. And you need to be careful all about this while securing your networks. We have IPv6 security statement 3. IPv6 networks are too big to scan. So the reason behind this statement is actually has some valid point. Common LAN and VLAN, they use all /64 network prefix, and in a single /network prefix, 64 prefix, we have this many hosts. So it doesn't seem that brute force is a possibility from now on. You cannot just brute force to this many number of hosts. It is also defined in RFC 5157, but we have new smart scanning techniques to have brute force scanning in the /64 networks. And I would like to share some ideas with you. So, as we said, as we have seen earlier in the first session maybe, or you already know it, we have two different parts in the IPv6 address. First, we have the network prefix, and the second, we have the interface ID. So, in order to be able to brute force to a network, you need to know both parts as much as possible, right? And for example, for the network part, we can just get information from the public who is data. And then you can check common patterns in addressing. For example, the network admins would like to use the first subnet, for example, for their own infrastructure. This is actually a common practice in the network admins, among the network admins, let's say. So the attacker will also know this and try to use this information if you are also using the first subnet. And what about the DNS part? You can also get data from DNS resolutions or from the reverse DNS resolutions as well. You can just walk through the IP6 ARPA the domain, and then you will get information about the network prefixes as well. And also you can just brute force on the addresses like index.html or index.php or similar addresses that is commonly used on the networks. So you can get information through the DNS information as well. And also, another easy way to get network prefix is the trace route. So you can just make a trace route to any destination on the internet, and you can just get information about the network prefixes which are being used through the network that you pass. So that's the network prefix part is relatively easy to get information about. But what about the interface ID part? Interface ID is again 64 bits, and brute force is no longer possible. But what kind of ways we may have to have a smart scanning on IPv6? Let's refresh our knowledge about the interface ID generation options that we have. So we have 3 different methods that we have seen. The modified EUI64, which is using the MAC addresses. We have stable semantically opaque addresses, which is recommended to be used for the stable addresses now. Most of the operating system uses this as a default for the stable addresses. And temporary addresses extensions we have, so they are changing over time. And we have other options as well. So we have seen the DHCP option. You can just assign addresses through DHCP. We have manual configuration option. And also, we have other algorithms like cryptographically generated addresses or hash-based addresses. So we have lots of methods to configure our interface IDs, but we still have some techniques to detect the interface IDs. So this is also another reminder for the stable semantically opaque addresses, but it is not needed anymore. I believe we already checked this. It is used as the standard for the stable addresses now. And what kind of features the attacker have to be able to attack on the networks? The first method is about the EUI64. So for example, we have our interface ID configured with the EUI64 method, which is based on the MAC address. So in the MAC address, if you know, there are two different parts. The first part, the first 24 bits, is about the manufacturer of the interface, the equipment. And it is called OUI. And since we have just a few number of manufacturers, the attacker will easily guess this number, the OUI 64, OUI bits, which is 24 bits. And while we are configuring our interface ID with the modified EUI method, we are also putting FFFE in between the two parts of the MAC address, right? So the attacker guessed the OUI and added the 16-bit FFFE, and now it has, or the attacker has, 40 bits long address already guessed. And the only thing that he needs to do is to attack on the brute force attack on the last 24 bits, which is much more easy than attacking on the 64 bits. So this is the first technique if you are using actually the EUI64 method to configure your IPv6 addresses. And that is actually why we say it is better to use stable semantically opaque addresses instead of EUI64 in order to be on the safe side. So in stable semantically opaque addresses, because we have no interface identifier defining the address. So it is hard to guess. The second method is about the low bits or the trivial bits. So after guessing the network prefix with the public information, then most of the admins may be using just colon 1 address to address their infrastructure. And maybe, and probably, this will be the most important device in the network because it is getting the number 1 in the network. And it is very dangerous, actually. You should not be doing it because it is easy to guess. What about the IPv4 based addresses? If you are, for example, using dual stack hosts, then you may want to have equivalent addresses for IPv4 and IPv6. And it is easy for you to remember, it is easy for you to check while you are troubleshooting, for example. And this is actually, this representation over here is a valid representation for most of the operating systems and for most of the vendors of the routers. It is a valid representation, and if you write this just like this, it will just convert it to the hexadecimal. So the first part is already hexadecimal, 2001 colon db8 colon 1 colon, and then 10 will be converted to the hexadecimal, .0, 5, and 5 will also be converted to hexadecimal, and you will have your IPv6 address. But it is also dangerous, because if the attacker has the knowledge of your IPv4 address, then it will be easy for him to attack to the IPv6 as well. So based on one protocol, it can have knowledge of the other protocol if you do this. And the fourth one we have is the service port. For the many services that are customer facing, for example, the web services or for the HTTP services, you may want to use your port numbers as the address, just like we have seen here with 80, or for FTP, for whatever it is. So it is also easy for the attackers to guess. What about the wordy addresses? They look cool, right? It is 2001 DB8 bed cafe. Actually, it is a valid address because it is hexadecimal and you can write it, but it is also dangerous because it is easy to guess. Many of the networks uses this. And last one is the sequential addresses. So with the sequential addresses, if you are using one after another, then you will have problem because if the attacker just learns one of them, he will continue the pattern, and you will get trouble for the other networks as well. So what we recommend to you, try to use interface IDs hard to guess for the attackers. Be careful about all of these techniques they know. And for the local scanning techniques, alternatively, we can say that attackers on the link may be also dangerous, and they can have more information about the IPv6 addresses, and they can have it more easily in your networks by just snooping the packets. Or there are other methods for information collection. They can get information from the dual stack hosts, for example, since it will be easier to scan IPv4 networks because we have fewer hosts in IPv4 networks. If somehow they can get routing packets, and we talked about this, if you make some mistakes to leak some information to the local network with the routing updates, then you may have problem because the attacker may learn this and can easily attack to the prefixes that you use in your core network or the other parts of the networks in your data center maybe. For the local protocols, we can say that they are used in the local network. That's why we call them local protocols. For example, LLMNR is used by the Windows. So with these protocols, also the attackers can get many information about your IPv6 addresses as well, and also the operating systems. So they will know that you are using some kind of operating system. And the local scanning techniques as well works for them. They can just send some probe packets to the network, for example, the neighbor solicitation packet to the all hosts on the network, or to ICMPv6 echo request packet to all hosts on the network, MLD packet to the MLD query packet to all hosts on the network. And if you don't take actions properly, don't take countermeasures properly, they can get much information than you can think of. So it is dangerous, and the best actually thing that we can recommend here, not to give access to your local network to the attackers. So that is hard to actually implement, but that is the best actually advice about it. So what about the fourth item we have in our list? IPv6 is too new to be attacked. So this is actually another. So are you talking about this one? This is no, okay. So is it the case now? Because IPv6 is already 20 years old, right? So is it too new? No, I don't believe so. The reason behind is again the lack of knowledge. IPv6 is happening, so it is not the case. And in reality, there are lots of tools and threats, attacks, security patches, firmware updates, and the best current practices, documents, threads, or forums about IPv6. So you can get many knowledge as you want. On the internet, IPv6 is not new thing, actually. You have to be prepared for IPv6 attacks. And I would like to convince you more about this. IPv6 is happening, really happening now. So the chart that or the list that you see on the left-hand side is taken from the Akamai website, which is a actually popular content provider. And we already have some countries which are reaching to the Akamai services with 100% IPv6. It is a small country, Bahrain, but we have already. And the other countries, you can see many of them are reaching to the Akamai web services with IPv6 addresses with more than 50% right now. This is updated actually recently. I have updated these slides in March. and it is increasing. And also we have some LARs in the list on the right-hand side, above of the graph. So you can see that in some LARs we have more than 70% IPv6 deployment, or we can even say more than 80% for some of them. So it is happening. And the last one we have here is taken from the Google website. It is, you can just search it in Google IPv6 adoption rates. So you can see that on all over the internet, the users of the internet are reaching to the Google services now with more than 40% IPv6 availability. So it is really happening. And we have also threats about IPv6. And as you can see here, this is actually an old one. We cannot find actually the newer version of it. It is Broadwire website, it was, but they just quit doing it. But it is still nice to see this actually, because as you can see, we have some unwanted email and web traffic with some IPv6 addresses, and also for suspect traffic analysis, we also have some IPv6 addresses. So it is real, it is happening, and we have some threats as well. What about the DDoS attacks in IPv6? We have some news for you here. So as you can see here, it is from 2018, and it says it's begun, the first IPv6 DOS attack, it says. And also we have, oops, what's happening? We have also another one here, which is also stating that the first IPv6 distributed denial of service attack, but it is from 2012. So the news are confusing, I know, but the message is clear, I believe. It is happening. We have threats, we have DOS threats as well, denial of service threats as well. So what about the fifth one we have here? IPv6 is just IPv4 with 128 bits addresses. I don't think that nobody is believing this here, because it is not just a longer version of IPv4. We have totally new protocol, actually. So IPv6 is totally new, and we have new considerations. But the reason behind this statement is we believe that it's coming from the way of the routing switching, how they work in the networks. They are actually working in the same way. So while we are routing our packets with IPv6, we are again using the longest match rule. So if you are familiar with this one. And we are again having the routing tables, and we are just comparing the destination address with against the routing table. So we are forwarding the packet according to the routing table. So it works in the same way. But the reality, actually, it is not just finishing with the routing and switching. The network is more than that. So we have whole new addressing architecture. We have many new associated protocols. So when you compare IPv6 versus IPv4, we can say that IPv6 quite similar to IPv4, many reusable practices. So we also gave some examples about the layer 4 protocols, and they are all carrying the same protocols like TCP, UDP. So you can define your rules according to your IPv4 needs in IPv6 as well. So you can use some parts of your knowledge about IPv4 in IPv6 as well. It is valid. But also we have some points that are slightly changing with IPv6 and also totally new for IPv6 issues, just like we have seen the extension headers or the transition mechanisms. So we need to consider all of these new concepts as well. For example, the extension headers. So here we see the some of them, and maybe these are the most common extension headers that is used in the networks. So first of all, we have the basic IPv6 header, and then we have an order, strict order for the extension headers, and the only extension header that is appearing twice is destination options here. So we said that it has special usage. You can just use it twice in a single packet if you are actually using the routing header as well. And all the extension headers, after all the extension headers, it should be followed by the upper layer protocol. So that is how extension headers also work. And what does it mean for us, extension headers? They are optional. So if you need some extension headers, you use them. If you don't actually need them, you just skip them. So it brings some complexity as well. So the security devices should process the full chain of headers for you, and they need to be aware of all of the extension headers, and the firewalls must be able to filter based on the extension headers as well. And let's check some specific types of routing headers here. So the first type we would like to check is the routing header, and I would like to introduce the header of this. So we have parts of the header. For example, we have the next header part. It is 8 bits, and it is just representing the immediate next header that is following this one. And we have length, which is actually representing the length of the header. We have routing type. We have different types of this header, and it is written here. We have segments length, which is actually stating how many segments we should visit before reaching to the destination. And we have the specific data, of course, which is actually listing the addresses that should be visited along the path. So what is the threat about routing header? The most dangerous one is the routing header type 0, and it is considered as dangerous because it can be used for traffic amplification over a remote path, and I will show it to you in the next slide. And it is now deprecated, and your security equipment, you need to check it. Most probably it is already applied, but it is better to check. The routing header 0 should be discarded at the edge of your networks because it is dangerous, it is not used anymore. So what is the threat with this? So we have this nice drawing here. The attacker stands on the left-hand side, and it is sending a packet from the source S to the destination D. So the basic header includes these addresses, but also we have another header, which is an extension header, and it is routing header type 0. And as you can see here, we have 127 segments to be visited along the path. So what are those addresses to be visited? It is going like this: A, B, A, B, A, B. Can you see the pattern? So when this packet is sent, this will be sent to the host A first, and then the host A will send it to host B. Host B will send it back to the host A, B, A, B, A, and the bandwidth will be exhausted on that link. And it is very dangerous. It is an amplified attack, actually, that can be easily done with the routing header 0. And eventually it will reach to the destination D if it is not discarded actually properly on the link A and B, but it will be consuming your resources. What about the solution? Yeah, we already said it. It is deprecated and it is not allowed to be used on the networks now. And it requires your security tools to inspect it and to inspect the header chain properly to just detect it. And now we are switching to another extension header, which is actually fragmentation header. It is used by IPv6 source node to send a packet bigger than path_MTU. So we all know how fragmentation works, right? But here you need to pay attention to the last part of this sentence. It is path_MTU. It is not just link_MTU, or it is not just the interface MTU. So you need to know the path_MTU in IPv6 because it only happens in the source node. It is not happening in the routers on the way. And the destination host processes the fragment headers. So the destination host will process it. And let's check the fields of it. Next header, again, just represents the immediate next layer. Reserved fields are for the reserved, and now they should all be 0. We have fragment offset actually, and I would like to draw your attention to here, because this is an important part of an attack type, fragment offset, and it represents actually the relative part or the relative place of this packet according to the fragmentable part, according to the start of the fragmentable part of the whole packet. So if you would like to put all the pieces together, you will check this field in order to be able to just put all the pieces together. So it should be following in a nice pattern, one each other. And we have mbit, which is stating that if we have more parts to be followed, and we have the identification, which should be same for the fragmented parts of the packet. What kind of threats we have for fragmentation? We have overlapping fragments. It is actually dangerous if the offset field is not matching or wrong information, including wrong information. It will be dangerous for some operating systems. They can just throw exception for it because the parts will be overlapping, and the defragmentation will not happen properly. And the second one is not sending the last fragment, waiting for the last fragment, and it will consume your resources. And the atomic fragments, actually, it means that the packet, it is the only packet with the fragmentation header, and you will have no more parts to follow this one. So it is only one fragment. It is not actually a fragment, but it has some valid usages as well. For example, for the hosts or the devices that is converting 6 to 4 to 46 in order to learn the path MTU of the IPv4 network, we use this kind of fragmentation. It has some valid usages, but you should be careful about it, and it should be processed in isolation. And also, I would like to explain the overlapping fragments a little bit more with this nice drawing here. So let's think that this is the normal process of fragmentation. So on the left-hand side, you see the full packet, and we have the fragments in between. So for the offset, we say the offset is 1 for the first part of the fragment. And for the second part of the fragment, we say it is offset 201, because this is 200 bytes, and when you add to the offset 1, it is offset 201. So when you combine it, when you put all the pieces together on the destination node, you will see that it is nicely matching, and you are again having the whole packet. And how actually happens the overlapping fragment? So the attacker will send you wrong offset number. So here you see that it is again 200 bytes and offset is 1, but the second fragment part will be starting from 120 bytes. And while you are creating the whole packet again on the destination side, it will be overlapped, and you will have problem with these kind of packets. And what are the solutions we have according to this? Overlapping fragments are not allowed, and the packets should be discarded if you see them. And not sending the last fragment, you should set a timer in order to prevent some exhaustion on your resources. The default timer is 60 seconds. For the atomic fragments, we cannot say that it should be discarded, because, as I said, it has some valid usages, but it should be processed in isolation with your IDS, IPS, or firewall devices. So you can check it also on RFC 6946. So what is next about the filtering part? Some information may be passed, or the attackers may try to pass through the firewall or the security infrastructure that you have without being detected. So they are hiding some information just behind the extension headers. So here, for example, in this one, we have basic IPv6 header and destination options, and then ICMPv6 array message, which can be dangerous. So if it's coming from an attacker, it can be dangerous because remember, we have lots of information in array messages. So for example, we have the default gateway. If you change the default gateway of the hosts on the local network, it will be dangerous, right? So it can be dangerous, and it is used by the attackers many times in the networks. So if you would like to prevent this, your security infrastructure should be able to detect these packets, and in order to be able to detect it, they should follow all the header chain that we have here. So if it is only looking at the next header field of the basic header, which is 60, it will say that, okay, it's fine. The next header is 60, which is destination options. Then it is okay to allow this packet. But it is not the case, actually. So your security infrastructure should be able to detect it. So they are actually good inputs for your POC tests while you are making some proof of concept tests for the firewalls, for example. The other threat about array filtering or array guard, the attacker can just hide the array message inside the fragmented packets. It is more dangerous actually because it is hard to detect them because for the firewalls, in order to be able to detect these kind of attacks, they should put all the pieces together to have the whole packet again to be able to detect the array message in the fragmentation. And it is not possible for them to put all the pieces together on the way in the real time of the traffic. So it is really dangerous, and we have some solutions for all of them. So they are not allowed, basically. You cannot use other headers inside the fragments. So we say that header chain should go into the first fragment. This is the second counter security measure we have. And the first one is about the fragmented NDP packets. It is not allowed as well. So you cannot fragment an NDP packet. And what about the other recommendations? You can check it on RFC 7113. So these are some basic knowledge for you, and you can check the other RFCs related. It again requires to be able to detect all of these types of attacks. Your security tool should be powerful enough to check the header chain properly. For the NDP features, we can say that actually there are some properties that we would like to mention to you. First of all, there is some kind of embedded security measure in NDP because the hop limit is 255. And if it is not in the packets for NDP, then it should be discarded. NDP has some vulnerabilities that are listed in these RFCs. You can check them. The specification says to use IPsec for all NDP packets, but it is not the case in real networks because it needs resources from the routers, from all the hosts. So it is not feasible now to use. It's impractical. And we also have another protocol which is defined in RFC 3971. It is SENT. It is secure neighbor discovery, we call it, but it is also not widely available. So these are the features that we'd like to mention about the NDP. So what are the threats about NDP? This is actually some kind of attack that is actually done with the neighbor solicitation and advertisement spoofing. Basically, in all kinds of attack based on neighbor solicitation and advertisements, the attacker will try to just change your neighbor cache. So it will try to attack to your neighbor cache in order to be able to change it properly according to him, and it will try to get the messages to himself. And in order to be able to do it, there are two ways: NS messages with the source link layer option changed, and the NA messages with the target link layer option changed. So in all of these messages, we have some MAC addresses And if the attacker can send these messages with the wrong MAC address to your neighbor cache or to your hosts on the network, then it will be able to change the neighbor cache on your device, and you will be sending the packets to the wrong destination eventually. So it can be result in a redirection or a DOS attack, actually, or it can be just a man-in-the-middle attack if the attacker can achieve to attack both devices at the same time in the same network. So they can get to the messages from here and send it to this one, and get the messages from here, send it to this one. So it can just position himself in between the communication. What about this sixth one we have? IPv6 support is a yes or no question. Actually, this is not the case. Actually, it is a set of yes or no questions. You cannot just say this. Question is, does it support IPv6? Yes, it supports IPv6. This is not a valid question. This is not a valid reply for IPv6. So it is not a yes or no question. It is a list of RFCs that should be supported. And for this reason, we have the RFC lists in our document, the famous document RIPE 772. For each kind of devices in your network, we have different RFCs to be supported. And for your RFPs, request for proposals, you can use this document, and it is a very nice document. I have also mentioned this in the last section of the last session, the previous session. So for the hosts, for example, you need to support these kind of features. For the switches, on top of host features, because switch itself is a host as well, on top of the host features, you need to also support IPv6 ACL, for example, or first hop security measures. So you need to support different RFCs, different features for all of these kind of devices in your network that you use. And it is a really nice document. They are all listed according to the different types of equipments in your networks. And what kind of security tools we have? So this is actually a non-exhaustive list of the security tools available for you. Those are actually open source. Most of them are open source tools that you can use in your networks. Most of them are available on Linux systems. So we have some packet generators, packet sniffers, analyzers. Maybe you already know Wireshark, or probably know. Specialized toolkits like THC IPv6 or the IPv6 toolkit or the EtherCap, sorry. They can assess your IPv6 security, and you can learn about new attacks with these types of tools. And maybe the most useful, one of the most useful ones is OpenVAS, which is actually a scanner for your network. So it can scan your network, finding the devices and information about them, and it can proactively protect you against the vulnerabilities, because it will warn you about the vulnerabilities as well. What about the IDS and IPS? We also have some open source IDS and IPS systems. You can try to implement them in your network. For example, Snort, Suricata, or Zeek are some of them. You can just assess your IPv6 security based on the information that you can provide through these tools. And the seventh item we have here, IPv6 is not a security problem in my IPv4 only network. This item or this statement seems very valid, right? Because you have IPv4 network, so why you need to consider IPv6 security? So it becomes actually, it sounds like nonsense, but it is not, actually. I'm sorry, but you need to consider IPv6 security as well in your IPv4 only network. Because the reason behind this, actually, maybe it is better to explain it first. The networks are only designed to configure and configured for IPv4. So we don't configure by ourselves any IPv6 device. But in reality, they are available, they are enabled by default in most of the operating systems and host servers and devices now. So you may have some unwanted IPv6 traffic, and you need to protect your network. And in IPv4 only infrastructure, you can expect some dual stack hosts like with the VPNs or tunnels. So your hosts, without you knowing them, they can just open some tunnels to some destinations through your core network, and you can have some undesired local IPv6 traffic, because two hosts can communicate through IPv6, right, in your network, because the IPv6 should be available or enabled by default on the operating system. Sorry. And you may have some undesired, unwanted local IPv6 traffic as well. And what about the automatic transition mechanisms? In Windows, earlier versions of Windows, for example, we had Teredo or iSetApp enabled by default. So they can just kick in and they can try to communicate with the servers outside of your network. And you also may have some problems with the rogue arrays. If you have some routers in the networks, we experience this while we are dealing with a problem actually in an ISP network. While I was working in an ISP back in Turkey, we experienced this. One of the networks, a home network, was having problem with the arrays, and we couldn't detect that where it is coming from actually. And then we realized that there is another old router, old CPE in the home network, which is just used for switching reasons. So they put it in the middle of the network to make some switching in the network, and it was sending actually the array messages, and it was just disabling the IPv6 communication in the whole network. So that is why we point this here. It is actually, you may have some problem with the rogue arrays, because it was sending array messages. So what are the threats about dual stack? Let's list them. The attacker will have bigger attack surface because we have two protocols now, IPv4 and IPv6. We have global unicast addresses, so it means that globally reachable unless you filter them. And they can use one IP version to attack to the other. They can collect information and they can use it. They can use that information to attack to other protocol. And what can you do about this? You can protect IPv6 at the same level as IPv4. That's why we say that you should check this feature parity between them. You can just filter end-to-end IPv6 properly, and don't trust your IPv4 only network. You may have problems with IPv6 as well in your IPv4 only network. And the last item in our list, it is not possible to secure an IPv6 network. This is not valid, obviously, right? Lack of resources and features. We don't have enough resources. The reason behind it, again, the lack of knowledge, I believe, and also considering IPv6 completely different than IPv4. So you think that there is no best current practices documents, resources, or features enough on the internet, but in reality it is not the case actually. We use IP-independent security policies. There are some best practices that you can share between the IPv4 and IPv6, and there are best current practice documents, resources and features, and lots of documents on the internet. You can use them. When you compare IPv6 and IPv4, we have seen this slide before, I know it, but it is again good to check it. We have some fields of IPv4 which are not changing in IPv6. We have some fields slightly changing, and we have some fields actually the new, totally new in IPv6, like extension headers, NDP protocol, ICMPv6, DHCPv6, we can count more. So the security tools, again, I don't want to mention this again, and we have lots of security tools for you available. You can just use, start to use one of them and start to check. Actually, in our face-to-face courses,
we are trying to make you familiar with some of them. For example, for the THC IPv6 or SCAPI, and you can join if you have time, if you have chance. You can join our face-to-face courses as well, which we will cover all of these topics in more broad way. And yeah, we have lots of tools about the IPv6 security. What about the rogue array solutions? So we talked about the array messages that can be dangerous in the networks. So we have some solutions against the rogue arrays in the networks. So for example, you can have link monitoring actually. There are some link monitoring tools which will help you to protect or detect the rogue arrays and protect your networks. So there are tools about it. You can use SEND protocol, but it is defined, it is in RFC, but it is not widely used. You can use manual configuration, so you can just disable auto configuration, but in a big network, it will not be scalable. You can use host packet filtering against the rogue arrays. You can just allow the IP addresses that should send you the valid array messages. You can have router preference options, but this will just actually protect you against the mistakes in the network, not the attacks. Because the attacker, we have 3 different levels for the arrays, low, mid, high. And if you set the valid array messages with the high preference, you can just prevent the configuration mistakes in the network. Because the attacker may also try to set the preference in the messages high. So it will not protect you against the attacks. And the 6th one, ACLs on the switches, we have, you can write it, but it is also another scalability problem, so it will be changing over time and it's hard to maintain. And the best option here in this slide is the 7th one, which is array snooping, or we, in some vendors, they call it array guard. And it works in like this. The switch will learn which is the correct router to send the arrays over time. And it will dynamically, it has the option to dynamically learn it. And it will just block the other array messages coming to the switch. So it is the best option to use. And including array guard also, we call all of these options, all of these security measures as the first hop security, because most of the time, switches are the first hop in the networks, in the local networks. So that's why we call them first hop security, or FHS in short. And they have lots of actually options like array guard, IPv6 snooping, IPv6 source prefix guard, IPv6 destination guard, MLD snooping, and DHCPv6 guard. And we check all of these in the face-to-face courses. So as I said, we have a full day course for all of these. For your routing protocols, you may have some authentication options as well. For example, for RIP-NG, it is not available actually. There is no authentication. IPsec is recommended. It is a general recommendation, but it is not available in practice because it's hard to use for the routers. It is resource consuming. For OSPF v3, we have options like IPsec again, but it is a general recommendation again, and authentication trailer. So you can use hash or OSPF version 3 values with a shared key. So most of you maybe you are using it with OSPF already version 2 about IPv4. And we have IS options like HMAC MD5 or HMAC SHA. MD5 is not recommended anymore because it is easy to attack, and SHA is a better algorithm to protect your networks about the authentication of the routing protocols. You are authenticating speakers of the two speakers of the routing protocol in this way. And for MP-BGP, we have 2 options: MD5, which is deprecated, which is obsoleted right now again, and the better option is TCP/AO, which is using better algorithms, 2 steps algorithms to protect the authentication between the BGP speakers. And what about the securing routing updates? Again, we were talking about the authentication between the different devices for the routing protocols. Now we are talking about the security of the routing updates that you send. So IPsec is a general solution for IPv6 communication, but in practice it's not easy to use. Actually, it is not used right now. And OSPF version 3 specifically states that ESP must be used with the manual keyring. So this is the only option actually that we have now. Unfortunately, for the other protocols, we can say that no options available now. And as the conclusion, we can say that security options are available for IPv6 routing protocols, and try to use them depending on the protocol that you use in your networks, OSPF, ISAS. I don't think that you are using RIP anymore, or maybe MPBGP you are using already. And at least try to match the security levels with IPv4. At least try to use the same level as IPv4. So again, we are at the end of our slides now, and I would like to once again recommend you to check the page academy.ripe.net, which is actually very useful. We have lots of information, and including these ones actually on that website. You can just work on your own pace and from your home. So it is easy to check, it is easy to follow. You can just get prepared for the examinations we have as well, for the certification examinations. And it's free for anyone on the internet. You can just have an access account and you can try to use it. And for the certifications, sorry, I need to drink a water. We can say that actually we have 4 different certifications now: IPv6 Fundamentals Analyst, RIPE Database, BGP Security, and for IPv6 Security. So you can try each of them. We will also have some facility for you to have the exams if you feel ready. You can already get examinated actually here. I believe that we have that set up. So it is more convenient maybe for you to have this exam here, but I'm not sure if you are ready, if you feel ready or not. And also, last thing from my side to remind you, and now we are trying to actually write a new course about advanced IPv6. And my colleagues outside this room, they are trying to collect information about this new course. And if you have any input about any parts of the new advanced IPv6 course, then please come to us. Please share your thoughts with us, because we have needs assessment, and it will be very helpful for us to build that course according to your needs, according to your thoughts. So if you have time, it will be very helpful for us. And I think that's it from my side. Yeah, that's the end of our session today. Thank you very much.
Dobar dan. Welcome to SCE 11 RIPE regional meeting. Welcome to Split. My name is Jan Žorž. I'm the chair of the SCE program committee. And yeah, welcome. It was a long way here for everybody. I'm really happy that we have people from so many countries from the whole region. Even from Italy and Romania and Ukraine and not just the region, but also from the outside, Poland. So I'm very, very, very pleased to be able to open this meeting. First of all, I would like to introduce you to the SE Program Committee. These are people that did majority of the work. We had the submission open for a long time. We received many good presentation proposals, and this was the people that rated them. We had 2 program committee calls, and yeah. So I would like to ask the program committee members in the room to stand up, please. Come on, PC Cats, up. So, if you have suggestions or comments about the program, talk to them, or to me, but to them. I'm just a chair. Yeah, so we have Zoran Petrovic, he's not with us today. Božo is there, Žarko, Vesna, Goran, he's not with us today. Ivana, here in the first row. Arjan from Albania, he's not with us. Vladislav, he is co-chairing this session with me. And also Eric, Andrej, he decided to go to GPF instead of here, so I'm remotely saying hi to Eric. Branimir, he's a newcomer, Sanel, and myself. A little bit of housekeeping rules. For questions, comments, and suggestions, okay, so this is the older version. When I mentioned Metico, I submitted a new version, and this is the wrong one. We don't use Metico here. So for questions, please go to the microphone. Go into the queue if there will be a queue, if there are many questions. Please state your name and affiliation, because this all is recorded and also streamed online, so people online can also understand what's going on and who are you. Big thanks to the RIPE NCC staff for all the help, especially Hans-Peter, Hisham, Alex for all the help with the organization, and everybody else from the RIPE NCC staff that is here. We also have a big honor to have Miriam Kune with us. She is the RIPE chair, the big RIPE community chair. She's the boss. And also big thanks to Carnet and to Goran for all the efforts that we can be here. Okay, we are still open for 1 or 2 lightning talks tomorrow. The lightning talk session is still not fully populated. So if you have an idea of some 10 minutes, 5-minute presentation that sparks in the hallway chat or during the social in the evening, and you want to present it like it's a pure lightning talk, please submit it to the submission system or talk to any of us, of these people that were standing before. And with that, my part is done. Thank you very much.
Thank you, Jan. And thank you for inviting us here. This is SE 11, as Jan just said, and we're happy to be back in Croatia. Our first SE meeting took part in Dubrovnik in 2011. Unfortunately, I wasn't there, but it's good to be back. So we are, I think, 19 RIPE NCC staff members here, so you can see all our pictures, our names and pictures up here. If you are interested in talking to any of us, please grab us, and we're more than happy to chat. The registration desk, you can find Alex and Van Min. It's really thanks to them that all the practical work is doing here. I mean, Jan is thanking me, but I'm just here to give this presentation, so I don't deserve any thanks. The service desk, if you have any questions regarding any of your tickets or anything else regarding RIPE NCC. They're here at your service, so please pay them a visit and ask them whatever you want. We also have 2 points of contact, Alex and Hisham. So if you experience something that is not good or if you don't feel safe, please contact them and they can help you with that. Jan already introduced Miriam, the RIPE chair, and we have a board member here, Piotr from RIPE NCC Executive Board as well. Social events, some say that that's the most important things at these meetings. It's not only about learning more about how to build the greatest and best internet for the future together, but we will meet tonight at the gala dinner at Gusar restaurant, and there will be a closing reception here tomorrow. And the Carnet, our local sponsor, has also invited us for city tours in Split, and you can do that tomorrow afternoon. Jan has already introduced the program committee, so I'll just skip that. And I will say a great thanks again to our local host, Carnet. Without the local host, this would be so much more difficult, if not impossible. So what does the RIPE NCC do? Well, you know us as the regional internet registry that you would come to for IPv4 addresses, although there are no more IPv4 addresses, so we still have IPv6 and AS numbers for you. But we also run the world's biggest and greatest measuring network. So if you're interested in hosting an Atlas probe, please contact us, and the more diversity we can have in the placement in the networks, the better measurements you can do. So you can actually use this network to do measurements yourself. We're producing internet country reports. The newest report is from Bulgaria, Moldova, and Romania. And the report analyzes the internet landscape in the region, not only technical things, but also the market landscape, competition, and potential growth. But of course, address-based transfers, V6 deployment, routing, traffic exchange, and so on and so on. If you want to learn more, we have extensive training programs. We are now back to face-to-face courses, and we have a new exam and e-learning course for BGP security. And you can take the RIPE NCC Certified Professional exams here at SEE 11 if you're interested in that. And if you have needs that are not covered by our existing learnings, please contact Evelyn or Pedro, who are here and are in charge of the development of future in training courses. So if you have ideas for them, please get in touch. We also have a looking glass into BGP, RIS, where we collect all BGP announcements from multiple points around the world. So if you want to see how your BGP announcement, what they look like in other parts of the world, you can look into this service and see what the announcements look like. And this is also historic data back for more than 20 years. So if you wonder what it looked like last week or last year, you can also do that kind of analysis in here. And we use this in RIPEStat, in BGP Alerter, and in the Internet Health Report. We also have, well, in the old days it would be a magazine or a publication. Today it's a blog, RIPE Labs, where you can share your ideas and perspectives, where RIPE NCC staff share this with the wider community, but also community members. Alan, the RIPE Labs editor, is here, so if you have any ideas, and he's sitting there waving, if you have any ideas for him, anything you want to publish, feel free to get in touch with him. And we also do podcasts, so here is a picture of Miriam being interviewed by Alan. We also have a community project fund. So if you have any ideas for projects that could benefit the internet in general, you can apply until the last day of May, and there is a community selected by community members that will assess the applications and award in a total of 250,000 euros. And once you've left here and want to continue the dialogue, we have mailing lists, of course, but we also have a RIPE NCC forum, which is a web-based discussion forum. So you could have a look at that for informal discussions, building connections, quick questions, and technical support. So that's open to everybody, even without an account. And that was all I had, so I would hand the stage back to Jan.
Yes, I apologize. I did not introduce. This was Hans-Peter Hollen, the managing director of RIPE NCC. Now I would like to invite Goran Škvorc from Carnet. He's the local host. We wouldn't be here without them. Thank you.
Thank you, Jan. Well, hello everybody and welcome to Split, welcome to Croatia. I had the pleasure to organize the RIPE SE meeting twice. So for me this SE 11 is a bit confusing because I organized it in 2011 and now we are doing it again, and it's a real pleasure to be here with you. After all this time I still recognize some names and some faces here. Božo, Jan, Arjan was supposed to be here, Arnold, Claudio, and so on. So it's really nice to see that the community is still holding together and it's vibrant and that you are guys doing a great job. On behalf of Carnet, I would also like to welcome you to City, the city where our CEO comes from. He apologizes he couldn't be here, but he wishes you a pleasant stay in Croatia. I'm not going to talk long. I just want you to feel comfortable here. If there is something that we can do to improve your feeling here, just let me know, and we will do our best. Thank you.
Radi? Yes. Now it works. Okay. Thank you very much. It's a big pleasure to be here. Olena Kushner. She's from Ukraine. She's representing the whole Ukrainian community. And we thought it would be a great idea that she would share with us some operational practice from Ukraine, how to keep the networks running, how to keep people connected during the war times, during the very difficult times. And just maybe we can learn how to make our networks more resilient and better in other countries. So please, Olena, the stage is yours.
Good day, ladies and gentlemen. It is a great honor for me to stay here in Split in the regional RIPE meeting, and we'll share some cool and some great regional success stories in the conditions of war. For those who don't know me, my name is Olena Kushner. I am the director and co-founder of WebPro company. It is a Ukrainian telecommunication operator and integrator of IT solutions, and also as a member, active member of some specialized association, including the Internet Association of Ukraine, the Ukrainian units of industrials, and as a Ukrainian LIR, my company, WebPro, also is a member of RIPE NCC. So, 10 years ago, I sat like you in the conference, and couldn't I imagine that Ukraine will be bombed, or the full-scale war started? Of course, no. But life gives us new challenges, and that make us more stronger. And every challenge gives us new experience, of course. Today, Ukrainian specialists overcome huge obstacles and bring telecommunication networks to the new level of stable operation. Here, there are some of the challenges we face every day. Blackouts, constant missile attacks, destroyed infrastructure, constant cyber attacks, dangerous working conditions for our employees, mobilization of employees for military services, and theft of Ukrainian resources. Let's start from the blackouts. As you know, 80% of Ukrainian energy infrastructure was destroyed by massive attacks. The operators made a number of correct management decisions. Home providers have actively switched to PON technology, but business providers have more difficulties because it was necessary to equip the main technical sites with serious uninterrupted power supply systems and generators. That's why we need for uninterruptible power supply systems is huge. Also, providers use Starlinks, especially in the cities from the occupation. In the photo, you can see, in this photo, you can see the Kherson city immediately after the liberation. People went to the central part of the town and just charged their mobile phones and to get the opportunity to call their relatives and just tell them that they are alive. There are incredible touching photos. And using the example of the provider Winner Telecom, I will say that their engineers in Kherson and Chernobyevka worked overtime and without days off, risking their own lives. This is an example of heroism. And we have in Ukraine a lot of such examples. Above is a slide here. This is a slide, Unbreakable Kyiv, in the hours of planning or emergency blackouts. Another know-how became shelters of unbreakability. There are hidden shelters where you can find free coffee or tea, comfortable working place, and of course, high-speed unlimited internet. Our company has connected free internet in 3 different cities in such shelters, and I think that another providers did the same. You can't even imagine what could be seen there. Many offices, students passed exams. While mom is working online, her child is watching cartoons near to her. And even beauty salon, because somebody haven't time to finish her manicures. That's why it was very crazy. But it shows that Ukrainians are really unbreakable. Of course, Ukraine is still subjected to a large number of missile attacks and drone strikes every day. And the telecommunication infrastructure in various regions of Ukraine is destroyed. The enemy is very active in attacking civilian and critical infrastructure objects. We lack equipment, materials, and engineers. And I found out about one ISP provider where the director by himself with the rest of engineers are working hard to build and restore fiber optic lines, because many of the engineers have been drafted into the military force, unfortunately. And on the 9th of March this year, when Russia launched 81 missiles in the different regions of Ukraine, some missiles hit energy infrastructure object, which led to a momentary blackout. And you can see on this drawing how the traffic flowed. The huge Kharkiv region, on the first place, remained almost without communication. I will say from my experience of my company, I know how to change 5 routes from Kharkiv, different routes, from Kharkiv to Lviv within 1 day. It is crazy. And next slide, it is a dangerous working conditions. Unfortunately, it is a sad story from one of the biggest Ukrainian telecom operator, Ukrtelecom. Akhtyrsky district still remains one of the most mined districts of Sumy region. A car with communications engineers pulled over the side near the destroyed TV tower. There were 4 people in it. The driver died. Others were seriously injured. At the bottom, here, here, in the bottom, on the slide, you can see a link to the Google folder where you will find many photos from the life of the telecommunication industry of Ukraine during the war. We risk our life every day so that the Ukrainian segment of the internet will not fragmented from the world network, and our people stayed connected. And the next slide is cyber attacks. It is a big problem in Ukraine now. In addition to missile attacks, Ukrainian networks have experienced and continue to experience massive hacker attacks from Russia IP addresses every day. But as a highly digitized country, we also stood our ground on this front and continue to fight actively in our field. I'll show you some statistic. I received this official statistic from a computer emergency response team of Ukraine at the State Service of Special Communication and Information Protection of Ukraine. Almost 3 times more cyber incidents were registered in the year 2022 than 2021. The total number of critical information security events originating from Russia IP addresses increased by 26%. And since February 24th last year up to nowadays, Computer Emergency Response Team of Ukraine has investigated 1880 of such attacks in manual mode. This one. More than a quarter of all the cyber incidents and cyber attacks were directed against the government, local authorities, and other sectors of critical infrastructure. Russian cyber attacks in Ukraine are often synchronized with ground and air strikes on civilian and critical infrastructure. And in the world, Russia's cyber attacks have become part of their information and propaganda machine. The diagram displays the top 10 source IP addresses in percentage that were here. That were identified as source of active scanning during the porting period. And you can see by format and signature the malware being distributed here. Since the beginning of the war, attackers supported by the Russian government has aggressively attacked not only Ukraine, but NATO member state too. Based on Google analysis, information about the Pusha hackers group, which is closely linked to Belarus. It is important to report this activity, after which it was strongly focused on Ukraine and its neighbors. I recommend to read this analysis, very interesting. Also, I saw 2 excellent articles that highlight the real situation in Ukraine with IP resources. As of February 2022, 2,197 AS were assigned to networks in Ukraine. In the last 12 months, more than 100 networks registration have moved out of Ukraine. More than 40 of these are now registered in Russia. In this table, it showed. And this is a 100 IS. But RIPE-NCC transfer data show that only the following 5 AS were transferred in the last 12 months. Do you know why? Because they simply update the country code. IP resources was in Ukraine and it became some Seychelles or Russia or Belarus and in other countries. Some networks disappeared from the global routing table. For example, on March 2022, AS number 6712 Format TV AS, based in Mariupol, disappeared from the global routing table. It returned after months, but with only half of the address space that it was using. Other large networks from the same region, such as AS number 57864, this is megabit, and AS number 35714, InfoService UA, also disappeared around the same time, but did not return it. There are people behind the scene, still operating. And here is another great article. And the internet services in Russia, controlled part of the eastern Ukraine, have been provided through Russia transit providers for many years. But last year, internet resources in Russia temporarily occupied Donetsk and Lugansk changed in front of the world, as if it were actually Russian. This region have received a type of Russification, an assimilation where the Ukrainian residents of this region have been forced to accept all things: Russian languages, currency, mobile phones, and telephone numbers, and of course internet services. The author of this article analyzes in detail many examples of how dozens of registration of IP addresses created by networks in Donetsk and Lugansk changed their countries from Ukraine to Russia in just the past year. In the temporary occupied territories, the occupiers steal not only IP resources, also equipment, other company resources, and completely takes networks under their control. They take control of the ISP's office and their technical staff, and then simply use private business networks. Traffic switching is one of the biggest problems in the occupied territories. Occupiers first of all turn off mobile communications from Ukrainian operators, and also switch fixed communication channels to the Crimea operator Miranda. Anyone know that Miranda Media is a daughter of Rostelecom? In this way, they take full information control of Ukrainian citizens who are under occupation, spreading propaganda and blocking Ukrainian resources. Employees and owners of such ISP companies who were unable to leave must either obey the occupiers and follow their orders or risk their lives. I spoke with one of the providers who did not have time to leave. He provided the internet to people until he has such opportunity. This led to the fact that he spent several times in torture cell. Luckily, he managed to live life with his family. The occupiers managed to take only part of his networks because the technical staff did not have access to the center technical sites, because he's a very technical person and he set up his equipment by himself. But how many of us manage our networks? I think that it can be units. I know another owner of ISP provider who is now abroad. He has 3 companies serviced by one technical director. After his office, the sales of the company and the technical director were seized, he lost everything in one moment. He doesn't even have access to RIPE's account because he never know password, and he now his post servers stole it. And after this story, I investigated that his lawyer turned to the police, and criminal processing were opened. Do you know what is the secret of the unbreakable Ukrainian providers? First of all, we love Ukraine, and we will find to our winner, and this is our territory, our land. And second, we learned to make very quick decisions, increase the number of reserved channels. We have some platform where we quick change of information and organize manual assistance. We are not afraid of complex challenges, and we are ready to use different technologies. learn new possibilities and apply them for quick restoring and building networks. Very quick example, when we drive in the car from Kiev to Kherson, we use Starlink and have online conference, and Elon Musk was shocked that it worked. And we also have our guardian angels. It is the Ministry of Digital Transformation that help us, and of course volunteers from NOC Alliance. Dear colleagues, I will not stop thanking you for your work, because your work is amazing and incredible. Thank you very much for whole our Ukrainian community. Thank you. So, dear friends, if anyone in this hall does not yet know about this project, please remember this face. If you have not yet had time to join the Guardian Angels of Ukrainian telecom sphere, I urge you to do it, please. And I also thank RIPE-NCC for assistance and cooperation of solving issues of protection of Ukrainian IP resources. We know that these issues are very complex and do not have easy solutions. But the most important thing is that we are moving in the right direction, and we feel your support. Thank you very much. And our Ukrainian delegation is here today because we are part of international professional community, RIPE-NCC. And we have a unique experience that we are ready to share with you. And Ukraine is strong, brave, unbreakable, and we are ready to open it for you. Thank you very much for your attention.
Thank you very much. Olena, thank you very much for sharing this information, and I promise I will never again complain about my working conditions. Never again. Are there any questions, comments? Lee? Does it work?
Hello, there we go. My name is Lee Howard. I'm with IPv4.global by Hilco Streambank. Thank you very much. This is really a great story to hear. It's wonderful to learn about how well so many people are doing in response to the challenges that you have. It seems to me that TCP/IP was designed 50 years ago, 40 years ago, to respond to specifically military conflict, right? It was a Defense Department project in the United States. And so we have dynamic routing, and the problems that we find with the internet that you describe are not problems with the protocol, they're problems with losing the physical connectivity, the power, and the people. And I'm wondering if there are best practices that we can learn from this and put into a best practices document that we can then learn from your hard work.
Thank you. I think that this theme is very important, and I won't focus it on this theme because we can share our best practice with the community. And as for me, the best to organize some department of volunteers from different countries which will learn our experience, because it is not first and not last war in the world, unfortunately. That's why we have depressed regions, we have regions in war. That's why, of course, we can teach, we can share our experience, and we must protect all members of RIPE-NCC, because this is a great examples when we lose our IP resources and other resources. That's why we must have some department here in RIPE-NCC. Thank you.
So, with my best kind of operational practice task force co-chair hat on, Lee, this is already something that we started discussing with Ukrainians and Alena and some other people. You're welcome to join the effort. I think we will talk about this in Rotterdam. I believe you'll be there, right? Okay, thank you. Come on, people. We have lots of time. Please go to the mic.
Liliana Petsu-Iliescu, North Macedonia, NGO sector, and I would like to know, in terms of impact of war, what are the lessons learned in relation to infrastructure resilience? So if we see people, process, technology, on which level do we start building the resilience first? So what is the lesson learned here? Thanks. Or recommendations, I don't know.
Yeah, first of all, you learn. First of all, after the war, you must visit Ukraine, and we will organize there a very cool conference with all members of Ukrainian community that will share more experience there, because my company, of course, have networks. We are operator of Ukraine, but we haven't a lot of networks in the south where destroyed. My colleague Victoria have experience of Wiener Telecom, and I mentioned her company. Of course, she can share her experience with you. But first of all, I think that we must be ready to use different technologies, different. All countries must have some platforms where you can communicate and help each other, because in our we have special platforms in chats where we receive some messages, hey guys, who have 96 fiber optics and who I need 1 kilometer, please help me. And it is a very, very fast decisions, and that's why, of course, we have success because we renovate our networks very quickly. And another, of course, it is a new technologies like PON, because for business providers it is harder, but for home providers, I must mention that in Ukraine we have near 3,000 providers. That's why, of course, it is not possible to have technical sites with generators and all sites, yes, but of course we can try, and we can use such technologies which don't need some electricity when something happens. And that's why, of course, welcome to Ukraine after our win, and we will share everything which we know with pleasure.
Yeah, we will try to gather all the experience possible, exactly how to make the national networks in different countries more resilient, not just to war, also natural disasters, distress, everything else. So it's sad that we need to learn this way, but yeah, it is what it is. Yes. Any other comments, questions? I see Vesna going to the mic. Please.
It's more of a comment and more to you about the best current practices. You mentioned natural disasters, but I also wanted to add another aspect, which is the climate crisis and climate change, and that is also asking for these kind of best practices to be shared, and that we learn from each other and from the areas that are more affected, because that is also coming for all of us.
Well, we can learn from Ukrainians on their side, but we also, with Keep Ukraine Connected project, we learned how from the outside help the areas in distress, and maybe we can also learn from that side and make it more general for also other things.
So do you have a concrete place where people who are interested in this can contribute to your discussion?
We can create one.
No, but the best current practices, how can people take part?
Oh, it's usually the meeting on Monday evening at the RIPE meetings. It will be in Rotterdam in May. So if anyone is interested in this discussion, please join the BICOP task force meeting.
And you can join to open house, Ukrainian open house, where some members of Ukrainian community present, and you can ask them all stories from first hand. That's why communicate with them. It's not a problem, but we have some problems with some business trips abroad to our men. That's why only girls today here.
Olena, I will let you off the stage now. Thank you very much for coming.
Thank you for your attention. Thank you.
Okay. Okay, it's time to continue with the program. We have the right chair next, giving us the usual update. So Miriam, the stage is yours.
Thanks for the introduction, and it's wonderful to be here, and thanks for the program committee to accept my talk. Maybe one thing before I forget, Jan, I think there's a mailing list for the BCOP task force group. Maybe you can share that on the list, and then people can join and we can start discussing some ideas on that. And then we can come together in Rotterdam. Yes, so get back to this. Yeah, I was actually at the very first SE meeting in Dubrovnik, and it was the first and last SE meeting I attended, so I'm really excited to be back here. And some people were making jokes already that I apparently decided to only go to the Croatian SE meetings. I love Croatia, so that I would be happy to do that, but no, that's not the reason. There were other reasons why I couldn't attend in the meantime, but I'm really glad to be back here. And I just want to give you a bit of an overview of what's happening in the RIPE community. And the PC has actually asked me to go into a little bit more details about the different working groups and what they're currently working on. So in case you're not familiar with this, and I also have some information later on how you can participate and how you can follow the developments. So I'm going to just cover a few developments that are currently being, or some topics that are currently being discussed in some of the working groups. And also some of the current policy proposals, like address policy proposals, some more generic discussions that we're having, and then also how we are reaching out to, keep the RIPE community growing. Yeah, so you've probably seen lately, there's an increased number of government regulations, proposals for new public policies and laws, especially coming out of the European Commission, but also other countries. And some of them affect network operations and therefore also network operators. And that's why we're coming together here in the SEE meeting and also in the RIPE community. And so there are a number of developments, a number of initiatives started in the RIPE community. I mentioned three here. One is a task force about best current practices for DNS open resolvers. I'll tell you a bit more about this. Another one is related to a consultation by the Commission about the future of electronic communications and infrastructure, and then another one is the EU Resilience Act. I'm just going to give you a bit of information here, not so much about the underlying proposals, but more the involvement of the RIPE community in this. And when I say RIPE community, I basically mean you all also. You're part of the bigger RIPE community, and so this will also affect you. Just to start with, this task force has actually started in response to an initiative by the European Commission to set up something called DNS for EU. That's in the meantime has been finalized and has been awarded to a consortium of DNS operators and then other organizations. And there's actually a company now, a consortium, that'll set up a public DNS resolver. Now, some people in the RIPE community, mostly in the DNS working group, but also in collaboration with the cooperation working group and also the best current practices task force, thought to use this as a motivation to write down some best current practices for operators of DNS resolvers. And so they got together. The idea already started in Berlin in RIPE 85, but they finally got together after the last RIPE meeting. There's a small task force. The link there is the link to the page that describes the milestones and the charter, and also link to the mail archive, so you can follow their discussions on their mailing list. And so the goal really is to write best current practices again. I think this is a lot what we are doing as a community, to agree on best current practices for each other. In this case, it's targeted to operators of public DNS resolvers. And so I hope we'll have a draft document ready before the next RIPE meeting. Another one is the relatively recently published consultation by the Commission, the European Commission, that's now called the Future of Electronic Communications Sector and its Infrastructure, was also known under Sender Pays or Fair Share. You might have heard of that. There was an initiative by some larger telecom operators who felt that it's not fair that large content providers and other operators don't contribute to their effort to further roll out internet infrastructure. And so the Commission took that on board and they issued a consultation, like a survey basically, that they've sent out to the public, to the community. There's actually a big discussion in the technical community and among operators about this. And specifically in this survey, there's one section that is relevant for us in our community, section 4, about the fair contribution of all digital players. And that's very kind of questionable. There's a big concerns among operators about this, about how this will go further. And even though there's a public consultation, we don't know what the Commission is going to do with this. So the Cooperation Working Group, which is a working group within the RIPE community that brings together government representatives and the technical community, that's been going on for many years, and it's a really good way to communicate, with each other across borders, if you will, between the techies and the government people. Governments come and talk about their concerns. Technical people come and talk about, certain technical limitations and also concerns they have with certain, like regulatory proposals, like this one, for instance. So the Cooperation Working Group put together a small group that are working on a feedback for this consultation. And they're regularly reporting back to the working group. So if you're interested to follow that, there's a link to a mail that has some more information about this and the Cooperation Working Group. And one of the chairs is actually here, Desiree. She is is she in the room? I don't see her now. She's the co-chair, one of the co-chairs of the Cooperation Working Group. So if you want to know more about this collaboration between governments and regulators and operators that's taking place in this working group, she's a good person to talk to about this. And then one third consultation or regulation that's been proposed that also created a lot of feedback and concern in the technical community is the Cyber Resilience Act that requires software developers to get kind of security certification, if you will, for their software, which is in itself a good goal. And as often with some of the regulatory or the government regulations is something has maybe unintended consequences. Right? It has a good goal. You want to improve the quality of software, but as a consequence in this case, it might have some impact for small operators and especially also small open source software developers. And that's a big concern in the community. There was a lot of feedback by various organizations like the Internet Society and Alnet Labs and some others also in the RIPE community. There is an open source working group. And so there's some information shared there on the mailing list. And so this act is not finalized yet, but there is a big call to basically clarify some of the language in that proposal to make sure it doesn't unintentionally kind of kill the open source community in Europe, because that's really not what the European Commission is trying to do. Right, so I know we don't really want to all, these regulatory and policy developments, they're really not something we want to deal with. So, but apparently some of it is affecting the engineers and the operators in the community. And a big thanks to the RIPE NCC to actually follow all these developments and communicating them back to the community, because I think we engineers, we wouldn't do how to, have other tasks and other priorities, and so it's really helpful. The RIPE NCC is helping with that. Different topic, also policies, but more maybe close to what our day-to-day work is address policies. So what's the current state of that in the RIPE community? Just a quick overview here for those of you who don't know how this works. You can see at the bottom there is the RIPE community, if you will, like all of us together. And part of that are the local internet registries, or the members of the RIPE NCC. So they're part of the community. And we as a community, we develop policies, like decide how many addresses are allocated to whom, under which circumstances, what kind of documentation is needed. And so there are a number of working groups. So address policy or policy in general, can be developed in principle by all the working groups in the RIPE community. Most of it is in the address policy working group, that's why it's called that. But there are also other working groups like anti-abuse working group or the database working group who have also developed policies over time. But ultimately, so there's a policy proposal, it's been discussed openly in the community, anybody can participate. You can subscribe to the mailing list and listen and participate via that, or come to the meetings. There are also a number of interim sessions that working groups have started to organize specifically during the COVID times, but they have also continued to do that, which I think is a really good development, to use the time between the RIPE meetings to have some online sessions and to continue the discussions that way. And so once the policy is, once there's a proposal, what is called a PDP kind of kicks in. That's the policy development process. There's a whole process that the community developed over time and how you develop consensus, how to discuss a proposal, what should be the goal of a policy proposal, and then what kind of format it should have. Once it's discussed and decided and there's consensus, it goes to the RIPE NCC, and the RIPE NCC is also part of that process because it does an impact analysis. It basically looks at the proposal and says like, yeah, this is doable, we can do this, or no, this would be too costly, or we don't have the staff or the resources to do this, or it would clash with some other operations. So the RIPE NCC definitely has a say in the way policies are implemented, but ultimately it's the community who comes up with these ideas and builds the consensus and discusses everything. Now once there's consensus, the RIPE NCC takes the policy and implements it to their members, in this case the local internet registries here, but it could also say members. So it's quite an intricate process, and it's sometimes hard to explain like the difference between RIPE and the RIPE NCC, but ultimately I think this is really brilliant the way it was set up at the beginning, to have that open underlying community that basically makes the decisions, and the NCC works with the community to implement them. Now, just as a background for those of you who we're not so familiar with this process. Now, there are currently 3 open policy proposals. The first 2 are currently being discussed in the address policy working group, and the third one is in the RIPE NCC services working group. I think the first 2 actually, the discussion phase has ended, and the last one is still open. So the first one is a discussion about adjusting the size IPv4 assignments for internet exchange points. The second one is a policy proposal to look at the temporary assignments for projects like research projects or conferences where people need a small amount of IPv4 addresses for just temporary use. So that will be adjusted. And then the third one is something that's related to what Olena has presented, and that's basically a suggestion to provide a way for anybody, any member, any local internet registry to temporarily or permanently kind of lock their allocations or their address resources and say, I don't want to have these addresses transferred for the next, or these resources transferred in the next 6 months or something. The NCC has actually implemented this on a temporary basis to respond to a call from mostly the Ukrainian community, but also a wider discussion in the community, and says, we do this, you implement this for the time being just as a temporary measure, and in the meantime, the RIPE community, please develop a policy on this. So there's a policy proposal out there, and if you're interested in this, I really urge you to look at that and provide some feedback. And I think some of the authors are actually here and can contribute or can answer questions. So just to summarize this, some of these policies will have influence on how you as members of the RIPE NCC, if you are members of the RIPE NCC, will have to do your business. So it's really important for you to also contribute and to keep track of that. And there's a whole page that links to it on the page there. There's a whole page where you can find more information on what the status is. And well, last but not least, of course, there's also IPv6. We've been talking about IPv4 policy proposals, but the Address Policy Working Group also took on a rather large task to actually review the current policies for IPv6. They've been evolved over time, they've been developed, over time. There are multiple documents, and so they sat together and okay, can we streamline this more now with the expertise and experience we have over the last 2 years? And they had one interim session where there was a really good constructive discussion, and we're talking about things like, does the HD ratio really is that still implementable? Or what kind of documentation do we need to provide to the RIPE NCC if we ask for IPv6 address space? Or should we make allocations on your nibble boundaries? So there was a good discussion on that. There's a summary of that on RIPE Labs, where you can see the link here, and there will be a follow-up session next week, I think on the 11th. It says there on the slide, it's on the 11th. If you're interested in that and in the future of IPv6 policies, and if you have anything you want to contribute to that, or you just want to follow that, it's open for anybody. You can register and participate. The anti-abuse working group, another working group in the RIPE community, also was quite active. A while ago, it was almost a year ago, there was a big discussion about a possible policy related to the anti-abuse contacts in the RIPE database. And as an outcome of that, the policy didn't go through, but as an outcome of that, it was suggested to provide more training and help and best current practices for abuse handlers and for people who are running an abuse desk at network operators. And so the RIPE NCC, together with the anti-abuse working group, developed this course, which is now out there. They had one instance of the course, and there's another one now, I think this week, on the 6th, I think even, that you can participate, and the link is there on the website. So that might be interesting if you're struggling internally also on how to do this. Is there any way to automate these reports or responses, and how to best respond to abuse requests? Another example of a fairly active working group is the RIPE database working group. They're doing things called numbered work items. It's a bit like action points, so they have a discussion. It's not necessarily a policy, but it's like an action point either for the RIPE NCC or for the working group itself to deal with certain items. And so there are currently 2 under discussion, and there is a whole page with all these numbered work items and what the status is and what that means, some background information, what the changes would mean in the database for that. So you can follow that as well. And I think that was all the examples I had from working groups. And there are currently 13 working groups. They go from, as I said, address policy, database, IPv6, also to open source. There's IoT working group, the cooperation working group I mentioned. So it's quite a wide scope of topics that are being discussed. And most working groups also meet during the RIPE meetings. So you can follow that. Now, in addition to these more topical and focused content-related discussions, we also do have some topics that are maybe relevant for the broader community as a whole. So I call them the community governance, like the policy development process, for instance. That would be a governance document that describes how the community develops policy. So there are a number of developments right now. There was a number of recommendations from the previous RIPE nominating committee to look at, for instance, in this case, look at how the RIPE chair could possibly be remunerated in the future. Like how could they, should there be a paid position in the future? And so there is a document that, in this case, the RIPE vice chair, Neil O'Reilly, who I believe is actually following this online, the session here. So he's developed this document, and it's on the RIPE list, and it's on the last call right now. So you can still provide feedback to that. Another 2 documents that are in last call, actually, that just ended yesterday, are related to the Code of Conduct. So the RIPE community has a RIPE Code of Conduct already for some time, and I believe that also is applied here at the SEE community. Now, what we were missing are kind of the procedural documents, how to apply this code of conduct, how to report a possible breach of a code of conduct, and who are the people who will then deal with these reports. So the 2 documents, the 2 missing documents, one about the reporting and how to select the team, I've shared on the RIPE list, and there were some comments, and there's now a last call that ended, and so we were going to publish that as two RIPE documents. It will also issue a call for volunteers to join this team. So you can think about if you maybe want to help out, be like one of those contacts at the RIPE meetings, and there will be more information in the mail I'm going to share with the RIPE community. And the last thing on the list is something that we realized a year ago or so when I started reviewing information, that the selection process or election process in this case for the candidates for the Numbers Council, for the Number Resource Organization, it's maybe something like very remote, very bureaucratic kind of committee. That wasn't defined very well. So we reviewed the process. There's a new document now that has all the relevant information in there, who can vote and so forth. And I will share that shortly with the community. So there's a lot going on. I have some more information here about the Code of Conduct, but I think I've said most of it, except there's a link for the actual Code of Conduct. There's the RIPE document already, and the other two documents I'll publish shortly. And last but not least, just a few words about outreach and inclusion. I mean, obviously we want the RIPE community and also the SE community to flourish and to stay relevant and to attract new people to the events and to the community, like we're doing with the fellowships, for instance. Me too, sorry. Should have brought my water there. So for instance, we've been doing, we already had childcare at the RIPE meetings, for instance, to encourage people to come to the meetings that don't have means to look after their children while they're at the meetings. We have the fellowship. We have also increased the remote participation, of course, for the RIPE meetings, thanks to the RIPE NCC. We're doing a lot more now. For instance, I'm developing together with the RIPE NCC a working group, or like a set of training modules for working group chairs, like for new working group chairs, like if you're interested in becoming a working group chair, or there's for the service. Thank you, sir. That's better. Yeah, so we figured that it would be helpful for working group chairs to learn a bit more what it takes to be a working group chair, especially for new people who might consider to become a working group chair in the future. Is this something for you? What are your tasks, responsibilities? It's all documented, but it's all just text, and so we're looking into some training modules to make it a bit more accessible. That's where it all says. Sorry, I should have clicked the button. And we also keep organizing events for students before each RIPE meeting to attract more young people also to the meeting. So there are two activities that we're currently working on, and I have a question here on the slide also. If you have any ideas, or if you have anything you would like us to do to include this community more, or to reach out more to you, or if you have any other ways you would like to participate, please let us know. And talking about new working group chairs and the training, there will actually be 3 seats available at the next RIPE meeting. So there are 3 working groups there, have their chairs and their term, IoT, database, and routing. And we always have, every working group has 2 or 3 chairs, so it's not like you're on your own and you're the new one and there's no one there. So we always have people to continue and help you out. So if you're interested in that, let me know. And yes, also another good way to actually follow what's going on are these quarterly reports that the RIPE NCC are sending to almost all the working groups about the projects that they are and the activities that the NCC is doing in that particular topic. Yeah, and that's about it. I mean, here's just a list of things for how you can follow what's going on. The very last link there is the monthly RIPE Labs update that Neil and I are usually publishing together every month to give you a bit of an update of what's going on, so you don't have to follow all the lists and everything like on a daily basis. And there are various ways you can follow current activities. And last but not least, this is the next RIPE meeting coming up. I think you've seen this before. I hope to see some of you there. And in the meantime, if you want to reach out to us, this is Neil, the vice chair, and myself. Our mailing addresses, and you can find us and contact us. Or just speak to me while I'm here, if I ever get my voice back. We didn't even party yet. What's going on? If it would be tomorrow, I would understand it, but today? Do you have any questions?
Are there any questions? And then there is a test in the next 10 minutes, because we are ahead of time.
There was a lot of information, I know, but anything that you are missing or any questions, you think like, I always wondered how the BCOP task force works. I don't know, something.
They can write an essay in 600 words about the information that you shared with us.
We still have 20 minutes.
Oh, well.
What do you mean? You want me to start all over again?
No. Thank you. Oops. Do you think that we should allow them more coffee? Okay, then thank you for the opening plenary, guys. Thank you, Miriam.
Thank you.
So coffee will be served, and we are starting the next plenary exactly in 4 exactly in 4. Don't be late. It's a very important thing going on that plenary. It works. So 1 minute and 18 seconds into the current session. Hello, everyone. Let's get this running. I see my co-chair is here. So let me introduce my co-chair, Ivana. She will be helping me on this session. This session is different with all the other sessions usually which we do on SE meetings. It was a very interesting idea which started from you, from the community, about getting an interesting thing about local development in the region of SE. This is our 4th iteration, and in order to get us on track on what we will be discussing later, I'd like to invite our colleague who worked very hard on getting this ready for you to enjoy, and then getting a set of remarkable people to discuss an interesting topic for the SE region. So without further ado, I welcome Jelena on the stage, and she will give you an introductory presentation on It Runs in the Family. So you, as our family, please enjoy the presentation, and I expect a lot of interesting discussion later in the panel.
Yes, thank you for a lovely introduction. Hello, everyone. Greetings to everybody in the room, but also to the people that might be following us online. Just a very brief introduction. So my name is Jana. I come from Belgrade, and I have been working as a community builder with the RIPE NCC for about almost 2 years now. Some of you might remember me from many different events, but specifically from the last year's SE meeting in Ljubljana, where we had a lovely chat about the history of the internet in former Yugoslavia. That was a rather brief, but I would say a glorious moment for our former country. And this year we're going to continue that story from a slightly different angle, but still the idea is the same. I wanted to understand how we got here, how we got to this point, and well, how we ended up with the internet that we have now. First, I'm going to give you a historical overview of the last 3 decades of the telecom evolution of the telecom market, but we are also going to touch and discuss later during the panel about what the future holds for the internet in the Balkans. And this is a very pretty visualization of the timeline when the national telecoms were formed, the first of these three parts, first decade in the 90s. I chose to start in the 90s because when we ended our story last year, it was with the breakup of the country in the first half of the 90s, and this is where we are starting again. And I just wanted to explain that the numbers, that the years that you see are the ones that where the telecoms were split, telecom services were split from the postal services. And I know that some of these telecoms do use different dates as their official founding years, but I chose this set just for the consistency's sake. And you can see that most of the countries are kind of grouped in the 90s with some differences on both sides. And when we move to the next decade, this is 2000s. And this was quite an eventful decade, and I would say a very important one for many different stakeholders. In my opinion, what was one of the key things that kickstarted the whole process of liberalization of the market and in some cases parallel privatization of the national assets was the fact that many of these countries have, by that point, have already started their process of the EU accession process. And that meant that they had to adopt EU regulations, EU standards, and those new regulations were introduced to promote competition, consumer protection, innovation, and many different things. Also important to note that EU also provided funding for to support the further development of the internet structure in the region. And as those markets started opening up, we saw the entrance of the new players. And very often, not very often, but typically these players, the result of that would be significant increase in the level of competition in the country. At the same time, countries saw increased foreign interest, foreign investment in many different sectors, but specifically in telecom sector as well. And this was quite important because these were, I would say, struggling transitional economies. So these type of contracts played a huge role when it comes to the general economy. And another thing that I wanted to highlight is that this is also the period where we started seeing the creation of the truly independent regulatory authorities across the region. So moving to the last decade, this is 2010s until now, I want to point out some of the characteristics of the current market. And in regard to the traditional telecommunication industry. Traditional telecoms are seeing the increased competition coming from many different directions, but the primary ones come from mobile virtual network operators and over-the-top services. And just very briefly for the people who might not be familiar with these terms, mobile virtual network operators are the operators that typically do not own the physical infrastructure and don't have the spectrum usage rights, but they rather rely on the wireless networks of the mobile network operator that they have signed a contract with. And they get to set their own retail prices. And typically, they are targeting cost-concerned customers. or rather people who prefer to have their internet cheap, at a cheap price. And that's the reason why whenever we see the entrance of the virtual network operators, we also see a decrease in the retail prices over the years. So another challenger to the traditional telecoms comes from these OTT services that include, so those are the media services that these companies offer directly to the customers via internet. And those include television, messaging, and voice calling that are, again, we are typically used to get those from telecoms. So, right. So that also leads us to the next point, which is change of the way that we access and consume the internet. Because I think most people by now have dropped using their computers and have switched to smartphones and other mobile devices. And also what we consume is different. Just to give some examples of the endless Zoom calls, online video games, or streaming Netflix or similar media, that leads to a growing demand for the high-speed internet. And telecom companies are in constant struggle to offer better and better services, but at the same time to lower the prices because this is the expectation. And they continuously need to invest more and more in the infrastructure, in the upgrade of the infrastructure, to be able to respond to the demand of the customers. Another change that is noticeable in this period is that regulators have started acting more like hawks of the telecom industry with a very straight vision and a task to protect the customer needs. And all of these factors together are driving the telecom industry to consolidate. And I just wanted to point out some of the trends that we're going to, that I would say, that I see dominating the industry in the next decade. I think that telecom companies are going to continue to finding different methods to respond to these market pressures. And one of the ways that they can do that is by internally restructuring, converging services, doing different types of integration. But also another thing that has a high potential of disrupting the industry is of course, the expansion of the 5G. We will see how that works out in the region and if it's going to have its full potential. So, before I move to the next slide, so all of these market pressures have resulted in a market that is rather consolidated across the region, with the emergence of a few strong regional players. And this is how it looks on the map. The data that we used is from the APNIC, the market share. And partially my own research when deciding, just mapping which ASNs belong to which network, and then which companies are a part of the same ownership group. And we chose these four because they're the largest ones. These companies are present in 4 or more SE countries. So that's just a very brief image, but if there's anybody who's interested in this, I also included tables with a bit more details that include the names of the companies and the year of the purchase or foundation. And when we wanted to look inside of these ownership groups, the first thing that we, across the whole region, it wouldn't be an NCC event if we didn't talk about IPv6. So this is, and IP resources. So looking into these countries, we see that in examples of, I think you can see the examples of the Montenegro, Croatia, and what was it? In Greece as well. You can see that majority of the IPv4 resources do belong to one of these regional players. And we're going to, during the panel, we're going to discuss what kind of effect does that have on the internet. So bits of the technical analysis from the NCC side. So comparing these companies within these ownership or family groups, how we call them, we wanted to compare how do these companies, well, how interested or involved and how much effort they put into IPv6. And the first company that you are looking at now is A1, but across the whole region where they operate. And to me, what's interesting here is to see that when it comes to countries like Austria, you can see that they do have quite a high percentage of their network, that their IPv6 capabilities are quite high comparing to other countries like other countries in the region like Bulgaria and Croatia and Serbia especially, and Macedonia. And then we can just go through different companies and look at what the numbers show us. And again, here we see that Bulgaria and Greece are doing quite well when it comes to IPv6 capabilities. But then some other countries like Croatia and Montenegro are kind of lagging behind the group leaders. Similar patterns across Deutsche Telekom, where the German is the parent company, is the leader, and then you see this local subsidiaries again are lagging behind the leader. Vodafone, it's a slightly different case because what we would expect to see is the parent company, which is registered in the UK, is not really the leader of the country, of this group, but is rather Greece. And then when it comes to RPKI, again we can see the whole group and just a second. Yeah. So similar to IPv6, we see that Austria is again a leader of this group, and countries like Croatia are significantly lagging behind. When it comes to United Group, this is a pretty picture because we can see that all of these subsidiaries are doing quite well, which is not the case with Deutsche Telekom, where again, maybe you can see that Croatia is at 0%, and maybe I hope that you already were able to see the pattern when it comes to Croatia as a host country, that very often we do see very, very low numbers when it comes to RPKI by IPv6 as well. So there's definitely room for improvement. And then the next measurement that we did was to look at how do these subsidiaries in the region, these companies, actually connect to each other. And on the left side, you will see on the y-axis, on the x-axis, you will see these companies in question. And on the y-axis, you will see the companies, the networks that they have significant dependency on. And often we would see tier 1 networks appearing there. But what is also interesting is that very often we would also notice the parent company popping up. So this is Deutsche Telekom, but I will show the examples for other countries as well. And when it comes to the blue cells, the stronger the color is, the stronger, the higher the dependency is. And this is based on the data snapshot from the 1st of January from the Internet Health Report AS hegemony scores. And on the right, this is the measurement that we did with RIPE Atlas, where we did a mesh measurement and to see again how do these networks communicate. And it pretty much confirms what we saw on the left side, where you can see, I hope that you can see, you will see the ASNs that belong to the networks in the region. But again, in the mix, you will notice that we have some of the tier ones. So that means that a path from Deutsche Telekom company in Macedonia, which would be Makedonski Telekom, to some other company, for example, Croatian Telecom, it might happen that they go through the parent company or through one of the tier ones. We don't really, so this is just what we are able to see using the RIPE Atlas, but it's almost never like a complete picture because we do lack probes, Atlas probes in every network, and sometimes the trace routes are also incomplete. But to the best of our knowledge, this is how the connectivity inside the paths available inside of these companies within the Deutsche Telekom group look like. When it comes to Vodafone, it's a slightly different image. As you can see, it looks slightly bit more centralized, right? And you can see on the left side, the color on the top is very, very dark blue. And the network that you see is Vodafone Europe. And on the right side, again, you see a centralized image with the same network. So that just means that the company, Vodafone Europe, that AS is extremely important and that all of the other networks are highly dependent on them. When it comes to United Group, it seems that Serbian broadband is another network with significant importance and that many different networks do rely on them. A1, it's a mix comparing to Vodafone and United Group perhaps, but again we do see in the mix a lot of, not a lot, but a certain number of tier ones. So the question is how come tier ones do appear when it comes to these cross measurements. So I explained to you that we would love to have the full picture, but this is not always possible because we do lack Atlas probes. And what we would like to have is to cover all of the larger significant networks so that whenever we want to repeat or redo these type of measurements that we can do that. You can see here the AS numbers of the networks that we consider to be significant in the country and where doing this type of measurements would make a lot of difference if we had a probe. So if anyone who is in the room or is following remotely is interested in hosting a probe, you can write to our team or myself. And I also have 10 probes, physical probes with me, hardware ones. So if there's anyone who is interested, you can just find me and I will give you a probe. So any questions?
I have a question.
Yeah.
Urban Suhodolniks, I'm a student at TU Graz, but I'm speaking for myself. I would like to ask how IPv6 capability was measured as things that actually have IPv6 and use it, or as capability in the infrastructure that might be or might not be activated?
I think it was IPv6 capability. It was the data from the APNIC.
Okay.
Yeah.
So it's better then. Thank you.
Yes, hello, Hisham Ibrahim, RIPE-NCC. To address that a little bit more, so what EPINIC does is they run measurements using Google Ads, and the assumption is that human beings will use Google. So if they can fetch information using IPv6, then the end user is capable with IPv6. And they take large samples, and they use that data to make the assumptions, is IPv6 going all the way to the end user or not? Yeah, thanks. It's IPv6 in use all the way to the end user. Yeah.
Okay, so our panel is starting in 5 minutes, right? So I would just invite our panelists who are in the room to maybe join us on the stage. So we will have Vesna Gaspar from the Croatian Regulatory Agency, Authority for Network Industries, HACOM. Thank you very much. And Christian. Is Christian here? Yeah. And Christian is joining us from Romania. He's a board member of the Interlan Internet Exchange Point. We will also have 2 remote participants, Slobodan Markovic from Serbia. Some of you might remember Slobodan from the last year. He was a panel moderator. So Slobodan is working as a digital advisor at UNDP, which is a United Nations Development Program. And the second participant, do we have everybody?
Oh, hi.
Ciao. And the second remote participant is Mr. Neven Dilkov, who is CEO of Netera, which is a Bulgarian-based telecom service provider. I'm just looking at the time. We still have 2 minutes and you can hear me, right? We still have 2 minutes, so I hope that in that time Mr. Dilkov is going to join us.
Hello.
Oh, hi. Thank you for joining us. So the topic of the discussion is going to be about how do we see the market evolving so far, and what are we seeing for the future? What does the future hold? especially when it comes to the characteristic that I mentioned, and considering that we do have a consolidated market with a few larger players, and what kind of impact does that have on the evolution? So the first, if everybody is ready, I think we can start. So the first question for for everybody on the panel would be, so how would you describe the current telecommunication market in our region?
Who shall go first?
Upaljam, yeah. Maybe after all these years from the beginning of the liberalization of telecom markets, yes, you mentioned we have 3 big players in Croatia, yeah. It depends what count of you are looking for. So we are small markets, yeah. We are less than 4 million citizens, but we can say we have few regional operators, little one. Today, after all these years, today when we are talking about telecommunication, we can say that we have 2 markets. Now we have digital markets and connectivity markets. So from my point of view, digital markets is something very important because convergence happened. So digital markets without telecom, we can say connectivity, is very closed and can't stand alone. So focus is now on that trends, we can say, because European Commission and all Union recognize that. That's why they published this debate regarding future of telecom trends in the next decade. So we can say that it's ICT markets, that's something we have to be focused, and that's very big challenge for all us from the telecom sectors. It's obviously that we all have to have a sustainable, reliable, and secure networks. That's why European Commission wrote all these regulatory acts regarding cybersecurity, regarding digital services, DSA, DMA, and regarding security, the last one is NIS2. So it will be a big challenge in implementation of these acts. So big, we can say, challenge for regulators, for policymakers, and for private sector, ISPs, and digital provider. Yeah. You want to?
Okay, I will continue with a point of view from Romania. So in Romania, there are 4 big players. What it is also important is that in the 1990s, I would say 92, 93, there were over 8,000 micro and mini operators in Romania, and now there are less than 500. So I would say that this is basically, these are bad times for small operators. And I think I will stop here.
I think this is a perfect lead to maybe to hear from Neven as a representative of the smaller operator. Can we say that?
Thank you, Elena, and thank you for the invitation for this forum. I think it's very important that we get together and discuss these things. So, yes, this is a very interesting topic, and I will start with a little bit of going back. You know, my colleague there from Romania was giving out some numbers. It was close to 30 years ago that, you know, the internet industry really started, you know, both in Romania, in Bulgaria, and in the other countries around here. And you know, during those years, the first 10 years maybe, we had, it is true, it's absolutely true, there were thousands of small, you know, small ISPs and operators that were operating, and I don't think that anybody from the population was complaining that there are too many. I think that everybody was happy that they have a choice, that they have a good service, and Romania and Bulgaria, for that matter, were regularly in the top 5 in some cases, not even top 10, of the annual State of the Internet report that that I was, you know, following, and that Amazon was publishing, you know, very regularly. They stopped publishing that from one point, by the way. So what happened, you know, after those years? The consolidation and the mergers and acquisition and all this process in the region has taken a very different, has created a very different view of the market. We have a similar situation here. We have maybe similar number of small and medium-sized operators left, less than a few hundred, and we also have three or four major operators. We have like 10 or 15 other that are medium-sized, and that's it. Bulgaria has dropped from any global ranks in terms of good internet versus quality. I mean, quality of internet versus prices. We're far away from the best countries in the world already. And the question is that a problem or is it not a problem? Let's state it from the point of view of is that a problematic process from a point of view of the law? And the answer is very simple. This is not illegal. It's not illegal to have mergers. It's not illegal to have acquisitions. The process that's happening in all these countries is quite normal from an economic point of view. How does that look from a standpoint of view of the regulators? That's an interesting point. The national regulators, in my view, very often do not have the necessary capacity, simply the capacity, not even the willingness, but they don't have the capacity of analyzing and preparing high quality and reports, high quality analysis of the competitiveness of the markets, their situation, the prospects and everything. And they very often rely on the European Commission and on the global, not global, the European Commission as an institution and the BEREC as a regulator in order to draw conclusions and plan their decisions. And for one or another reason, I think that the European Union in general and the European Commission in particular have much bigger problems to solve in the past, had much bigger problems to solve in the past 10 years, 10, 15 years, than the telecommunications industry. Unfortunately, I would say for us in this industry, we started off with having very, very good services everywhere, or in most places in Europe, including in the Balkans, which for the regulators was a very strong signal that they don't have to do much about it, and they let it go, the way it is, the way it should just, naturally develop, and it happened what happened. I have to say that I don't see any prospect of that changing in the near future. We have a war that is right next to our door, and we have a very, unpleasant political processes in many of our countries. This is not going to change. So from a regulator point of view, everything is fine and dandy. We're all happy. Customers have what they want. The prices are not too, too expensive. Let's go and have another IKEA and be happy. But let's look at from a standpoint of view of the consumers. And I would dare say that this is the most important point of view. Now, we are all saying that in our countries we have two or three, like three or in some cases four major operators that control, in some cases, 80% of the market in some of the countries and some of the segments. Like, for example, in Bulgaria, this is the segment of bundle services that include mobile service. Clearly, only the mobile operators can have such bundle because only them, only they can provide mobile services, and the regulators would say that the competition is good enough. And I have a very interesting, I have a very simple question for that. If you go to France, for example, and ask them, would you be happy if there's only 3 suppliers of cheese in the whole of France? Or if you think that there is, it's okay to have only 2 suppliers of wine in the whole of Germany, would that be considered acceptable? I would expect that to be unacceptable for 90% of the population. But because of the good history of the telecommunication industry, we can accept that it's been good. It's been so nice in the past. So it cannot get so bad. But is it really the case? I can tell you that in Sofia alone, there used to be tens, not hundreds, maybe, but close to 100 maybe, just in Sofia, small and medium size ISPs and cable TV companies. My company Netera was actually relying on that market because we needed to have reliable and cost-effective access to all locations in the whole country, for that matter, but in Sofia in particular. And in the past 5 years, we discovered that this is not the case anymore. Not only is not the case, there's almost none small and medium-sized operators in Sofia left. So we were basically forced to build our own fiber network inside Sofia, which was the first new independent fiber network built here for the past maybe 10 years, and actually more, because nobody needed such thing, before. And now, when there is, it's just the handful, less than a handful of big operators offering services that are obviously very aggressive and don't want to let anybody else work there, it kind of becomes important. There are hundreds and thousands of complaints in the Commission for the Protection of Consumers in Bulgaria from the large telecom operators, because being aggressive and trying to make increase the profit and the ARPU and all that stuff, which is all completely legal, by the way. I always say that being greedy is not illegal. If somebody lets you, eat the cake, you're not guilty of eating the cake. That's a Bulgarian saying, by the way. And that there is not much that they can do, because the only force that can improve the services on the market is not giving more to the big operators, but increasing the competition. And this is a ongoing battle, I think, and it's not going to end anytime soon.
And I think this is a perfect opportunity to hear directly from regulatory agency. How do you assess this or respond to the claims of lack of capacity of the agency to deal with these market dynamics?
Sorry, I didn't understand very well because of the connection. But I heard something about regulatory issues, and that you don't agree with the dynamics of the regulatory actions. It's not timely and.
It is different in the different countries, I have to say, but in general, I'm also the chairman of the board of directors of the European Competitive Telecom Association. This is the association of alternative operators on the European level and one of the strongest voices that supports competition on a European level. And what we see on a very high level is that it is really complicated. Like, for example, any market analysis, any action that a regulator may take to amend or to help a certain market has to go through a very detailed market analysis. And the methodology of doing a market analysis is such that you may need to spend between 2 and 3 and sometimes even more years just to be sure that you are doing the right stuff, you're collecting the right information, so that when it goes to real market activities, I mean like regulatory activities, it's not going to be overturned in the court when the operators, for example, the big operators complain in the court and they bring up all their, their lobbying efforts and, their marketing budgets, behind them and their promises of large investments and all that stuff. It's very difficult. That's what I'm saying. So it's not easy. This is my point.
I'm not aware about situation in Bulgaria, but from my experience, we usually have these ex-ante regulations, and according to that, I think for regulator is the most important to have fair, proportional, and timely action. So we used to do it. Acquisition happened in Croatia, and maybe something wasn't so well, but we have about 5 regional operators. They made their niche in regional access. I don't know, for example, deployment of the fiber on just one county and some business model. And we have 3 big operators. They are rolling out today currently. They have some obligation regarding 5G coverage. Currently, we have, if we want something to make obligatory for them, we have only 2 wholesale products. So with symmetric regulation, I think the things have to be right regarding competition. So that's my point of.
But I do have a question on what kind of methodology do you use at Hacom to assess each case of a merger and acquisition that is brought on your table?
Particularly in that situation, we don't have power regarding that, because another regulator, a competition regulator, is in charge for that. We just send our opinion in that procedure, and we looking deeply in the revenue share on the market, on that particular market, and send our opinion to the competition regulatory. And usually they are judged about that acquisition. So that's the procedure here.
Okay, but Is it possible to tell us a bit more detail on how do you form that opinion? How do you form that official opinion that you then forward to the other regulatory agency?
Based on the statistics from the end users, for example, customers base, revenues, and regarding some competitions practice from the competition law.
And in some cases, have you had a case where you had to put certain conditions for that merger or acquisition to go through?
Sorry, can you repeat?
Do you sometimes take a case, a very specific case of acquisition, and then say, we can allow this, but under very specific conditions?
We can't say that we can allow it or not. We just have our expert to the competition authority.
Okay.
Yeah, I think that what Elena was asking was how many. Can you give us any cases when you actually recommended not to be approved, a certain merger, for example, or acquisition to be approved, or how many cases you have issued an ex ante regulation to be implemented, by the operators?
How many cases we approved? We don't.
How many have you recommended not to be approved?
Not approved. For example, on the beginning, when HT want to buy first ISPs in Croatia, Iskon, we didn't approve that, and we sent our opinion to the competition authority. But in that time, it was prescribed by the competition law some threshold. So they were under that threshold, so regulatory competition agency approved that. We were against that.
Thank you. Thank you.
And sorry to keep you waiting. Slobodan, do you want to chime in with your perspective from Serbia? How do you see the market in Serbia in regards to the conversations that we had so far?
Thank you, and hello everybody from, believe it or not, snowy Belgrade. It's April, and it feels like, middle of winter. So I kind of envy you, the seaside. With regards to what's been happening in the telecom market in Serbia, the past 10 years were marked by really explosive growth of mobile internet use. And it was powered by 4G and the rise of, what the incumbents called the OTT services. In the first part of the decade, actually this demand was being met on the part of the infrastructure by the cable operators. So they were investing a lot in fast internet, and Telekom Serbia, which is the incumbent, was really lagging until maybe 6 or 7 years ago, when they started heavily investing in fiber optics. So this picture changed a bit in the previous couple of previous years with this rise of a fiber optic by Telekom Serbia. Of course, the other cable operators also started, rolling out mostly, hybrid coaxial fiber optic infrastructures. So we have seen, developments in that part as well. But Telekom Serbia really changed this picture in the recent years. And this combined, fiber, cable, and mobile infrastructure, and of course, in some places where this modern infrastructure doesn't exist, we still have, like the old copper and VDSL. All of this provides, like a decent coverage, I would say, at relatively affordable prices in most areas. But I would say that the biggest problem is actually user choice in many areas. It really doesn't exist in many places. So despite the fact that you have, on paper and in statistics, many operators, you really sometimes really don't have a choice. And you have to stick with, one operator. I think that this situation should be monitored much more closely by the regulators, and it is not easy, really. The operators really need to collect a lot of data from many sources on the availability of services and the quality of services in different areas. But it really provides a better picture, I think, and insights, and of course input to the government where state intervention might be needed, for instance, with regards to rollout of the new infrastructure. We have also seen some consolidation in the cable market and some in the ISP market, mostly again by Telekom Serbia in recent years. They really wanted to regain their position in bundled services over fiber and cable. And they also invested a lot in content, buying rights for major sports events and producing TV shows. I see that this shopping spree ended approximately a year ago, but really we haven't seen a major new entrance in the market, which is I think interesting. And the market is, generally speaking, still very much concentrated in most segments. So you can see in most segments just a few big players like Telekom Serbia, Serbia Broadband, and in the mobile you have A1 and Yetel. This is former Telenor. The Competition Protection Authority didn't pay too much attention to all of this. So we were left with a Serbian Agency for Telecommunications, which applies these like ex-ante activities, but they were, again, in my point of view, not too effective in ensuring fair competition. And I mean, I can't say that they didn't do anything, but they could have done much more to ensure better conditions for alternative operators, infrastructure access, infrastructure sharing. And I mean, of course, they still can and they still should. So I would encourage them to dedicate themselves more to this. And I don't want to talk more, about too much about consumer protection, and it's a whole different topic. But I just want to mention the universal service provision, which wasn't that good over the past 10 years in Serbia, and the law, for instance, was never implemented to the full extent in this area, and this mapping, which I mentioned, lagged for many years, but it was eventually done. And preparation to ensure, state funding for covering these like white areas also took some time. So this whole rural broadband project is just starting, and I think it's great that it is starting, but it took really a long time. And looking forward, I think that it's obvious that Serbia is lagging behind in 5G. We still haven't got the auction for frequencies, and also the overall legislation is also a bit dated. The existing law on electronic communication is more than 12 years old now. So I think that these things are urgently needed, and I hope that this year we'll see both the new law and the auction. Of course, demand is still strong and going strong. Video is there, of course, and more users are using, government digital services, e-commerce, and entertainment. And of course, this whole new wave of generative AI applications and virtual reality and augmented reality will also contribute to this growing demand. So this is why we not only need a better mobile infrastructure and new generation networks, but also improve legislation, because if you want to take advantage of the 5G networks, you need to have much better legislation for laying down, putting base stations or laying down infrastructure, to streamline this in legislation. So we'll have to do a lot more. And my general point for all of this introductory part is that you really cannot have one single thing that you should do to make things better. It's there's a lot to be done in many areas, and many fronts by both, the government and the regulators, and eventually the market. And the sooner and the more is done, the better in general. So that would be all for starters. From
I have a follow-up question for you.
I hope you won't mind, but how would you assess the rivalry between these dominant players in Serbia, but maybe you can also give us the regional perspective? Do you see that these companies keep a close tab of what their competitors are doing and trying to keep up with them?
Well, I mean, yes, to a large extent. I mean, and some operators are quicker in introducing some services than the others, and then the others follow up. So at some point, a couple of years back, when A1, for instance, introduced good tariffs for some zero-rated services and generally bigger internet packages within their offering, it was quickly adopted by the other operators as well. So I mean, the things are changing, but I mean, this whole dynamic is limited when you have just the 3 players. So I mean, perhaps this 5G auction could be an opportunity to open doors to more competition. For instance, the United Group applied, expressed the willingness to run an auction for 5G frequencies in Serbia, and I think that they should be allowed to do that. I mean, I don't know whether they are going to stick to their commitment, but it's really tough. I mean, you're left with a limited number of players, and it's an uphill battle, I would say. So this is why I say that the regulators should focus more on the users, and empathize with them, basically, and not only rely on statistics and rely on some regulatory possibilities, like say, okay, we have like a growth in our telecommunications sector, and the user have the right to change their operator and retain mobile number, for instance, while effectively you don't have the possibility in your neighborhood to switch operators, for instance. So I think that this this user experience should be followed more closely, and regulatory measures should stem from these insights.
Thank you. And speaking of 5G, I'm very curious to hear from our panelists, how did the auction go in your country, if it was finished?
We just recently finished our auction, the rest of the frequencies. A year ago, we assigned some frequencies, and last month we assigned the rest of this, and it was we can say very successful auction, because we earned for the budget, the state budget, about 340 million euros. It's double that we expected. There is some regional new player, on the auction. I think Eolo, some Italian company for some few counties on the seaside. And we have some expectations regarding rollout of 5G in the future, because we are not satisfied with some rural coverage, so we expect that they will cover that some kind of counties, and in combined with some fiber deployments, further deployments, with EU funds. I think that's the good direction, and we will see what will happen in a few years. We have all very expectation regarding this new services, new vertical slicing, and all that possibilities for the new players. Maybe some industries, completely different industry players in this, but we will see what will happen.
And was this decision to allocate these frequencies on the county level instead of the national level did that take into account that by doing that, you might attract more of the new players? How did you, do you know how was that decision made? And is that typical or atypical to award licenses on the county level instead of, the whole country?
I'm not expert in radio communication on all these procedures, but I noticed that they set conditions in direction that we can stronger competition. So we will have, we hope so, yeah, new regional players for 5G frequencies, but we will see what will happen in the near future.
Okay. So can you tell us more about Romania?
What I can tell you about Romania, I think it's something that could apply to all these Balkan countries. I'm going to take this hat off and I put the hat of the small operator and not a board member of any kind of thing. Basically, what I'm doing, I'm fighting with toothpicks against Javelin missiles. I don't have money to go on TV. Whenever I want to link an end user living in a house with a 10 euro monthly payment, I have to pay 9 euros for the 30 meters fiber link, and from those 9 euros, 7 go to the city hall. So basically, it's like paying an indirect tax to the city hall, and I don't understand why. Is this something wrong to live in a big city, so you have to pay even for the air you breathe or for 30 meters of underground fiber? I think that, and I'm not asking for a different treatment, but an equal treatment is not a fair one from the regulator, because the regulator is asking every year around 200 pieces of papers with hundreds of check marks about 5G, about 3G, about I don't know how many G points that I do not use. It takes me 1 week just to say no, 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 because I am not delivering these kind of services. What I would like and what I would consider a fair treatment, just send me the damn paper, half of it, with the services I am providing. Because you already know, as a regulator, what services I am providing. You are asking me for this. So it's like, I just love the cheese one. I am producing camembert, and you are sending me a paper asking me to say that I am not providing brie. Well, I'm not, but you already know. Why do you ask me again and again and again? So, it is impossible and it is not normal for any kind of agency, a private or governmental one, to make differences between operators. But what you can do is to find the fair point. Ask people whatever they provide. Don't go and make them dig big holes with lots of paperwork, especially when we are talking about micro operators. Micro operators have only one employee, who is the factotum. He is doing business management. He is managing the company. He is working on switches, routers. He's answering the phones. He's billing. Basically, he's doing everything. What the regulator does, he just doubles the work for nothing, without any impact, because you are talking, how do you find your answers via statistics. But when you have an operator, a micro operator, I mean an operator with 200 clients, he just makes a living for himself and his family. This is 0.01% of that statistic. He just doesn't count in the big equation. And even you multiply by 100, you will reach 1%, which doesn't count. What counts are those four big players. What I want to say is that, in my opinion, the regulator should keep a healthy system, meaning the regulator, like a doctor, should say, you shall take 1 shower a day, not 10, because you will destroy all the bacteria, including the good one. What the regulator is doing now, he is saying you shall take 100 showers a day to have a very, very effective system, which kills the good bacteria, in my opinion, the micro operators. So this is what I think that happens. I'm just asking one question. When there will be 3 operators and none of these small ones, what stops those 3 operators to add a leading 0 to the bill they are sending to their clients? Nothing. And as this is a contractual thing, the regulator won't be able to say anything. Opinion about Romania. Thank you.
So if I got right, you said that the problem are at the same time under-regulation and over-bureaucratic.
Exactly.
Okay.
And not only this, but I am trying to state only the most important factors.
Yeah.
I said that I will stop here because I want to state only the most important factors and not going into details.
Thank you. I would like to hear from Neven. The question that I asked a few minutes ago was about the 5G auctions, and maybe you want to share the updates from the Bulgarian side. How did the auction go?
Yeah, thank you, Yelena. The short answer, from a standpoint of view of a market effect, like effect to the consumers, I would dare say that in any of these countries, it doesn't matter. It doesn't matter how the 5G auction went, because this auction is not going to. And wherever it happened already, like in Bulgaria, it did not change the competitiveness of the market and the landscape, the options for choice for the consumers. No, it did not. So it doesn't matter how it went from that point of view. Having said that, the experience in Bulgaria is quite different. Just for it's almost like a joke because it's so different. It's very eye-opening what I just heard from the Hungarian regulator. Sorry, I'm sorry about that. The Croatian regulator, because it's contrary to what happened in Bulgaria. In Bulgaria, the regulator has taken the approach that the frequencies and the mobile operators should not be charged a lot, because the logic is if they pay a lot of money for frequencies, they will be asking them the end users to pay that money back, right? So the consumer will be finally punished for the high fees that the state is asking them to pay. So let's see what happened in Bulgaria following this logic. There was a procedure last year for 5G frequencies. Before the procedure, there was more than a year of a public consultation where the regulator, the telecom regulator in Bulgaria, quite different from the regulator in Croatia, worked very hard to prove that there is a necessity to lower the fees for the frequencies. The procedure was held 1 week before a new law was introduced that was supposed to make it a bit more difficult, slightly more difficult for them to do what they did. And the mobile operators paid a total of, I think, let me read, 6.5, if I'm not wrong, million euro in total, all of them, for the next 20 years to use the 5G frequencies. You can compare to what this nice lady over there told us about Croatia. So you may think that this approach made them very happy. They decided to lower the prices, so the consumers were also happy. No, they did exactly the opposite. At the end of last year, all mobile operators, in a concerted effort, increased their fees by 15%, citing all kinds of reasons, with inflation and stuff. So the result was the opposite. So what would you think the regulator did next? Well, they just came up with a new decision to lower the prices of the further frequencies that they're supposed to be getting between 40 and 70%. So the next batch of frequencies they're going to get is going to be even cheaper. So this is the Bulgarian experience. Having said that, one of the organizations that I participate in, we complained to the courts for certain discrepancies in the procedure. Namely, we went to the courts and said, this is not the right approach. Giving away free frequencies or almost free frequencies to a small number of operators does not help the competition on the market. What would actually help it if the regulator would say, yes, great, we're giving you these frequencies, almost free of charge, but we would require you to open up your networks so that virtual mobile network operators, MVNOs, could show up and start offering more services. There is a more diverse market then, with more options for consumers and so on and so on. And we claimed that that this is the right approach. The approach is not to invite more operators to, because on paper those tenders are open. So anybody, like 2 or 3, maybe more operators can show up and say, I want to build another network here and then compete with the rest of the mobile operators. This does not happen because in a small market like Bulgaria, and all of our countries are not very big, it doesn't make any sense in building even 3 networks, if you ask me, but 4th and 5th, it's completely out of the question. So inviting more companies to build more networks, even for cheap frequencies, is not going to work. Quite on the opposite. If you want to help the competition, you should make sure that the existing networks are used better. And what I gave as an example is actually a very good example. Bulgaria is one of the few countries in the world that does not have MVNO operators, and that was our claim, to the courts. The court came up with a decision in our favor, not because of this logic that we came, but because of procedural reasons. And now the regulator is forced to do some changes. We will see what happens. They have already come up with a new decision yesterday, for that matter, that they insist there is no problem with competition on the Bulgarian market. I think this is severely flawed, logic, and it is what it is.
We do have a question from the audience.
Okay, thank you. Vladislav Velikov speaking for himself, but interesting input on the Macedonian situation. We were lucky in the few years ago that our regulator was well equipped with the tools to keep the market running. But then something mysteriously broke. I don't know what happened, and things started to the famous Balkan way, 2 steps forward and 3 steps back. And 5G was a very not a good example on how things should be done. They did the licensing, the 2 big operators got their licenses, they're starting to develop their network, and interesting things happen. First, the quality of the general services which are not 5G is terrible, and each time you say something about it, it's, well, we are developing our 5G network now, this is why service is bad, and this is actually tolerated by the regulator. The second problem was that imagine after they developed the technology, the 5G is a premium you have to pay €2 to business customers in order to use 5G services, although you still have to have a 5G phone. On the other thing, some mergers created an unfair position in the frequency band, because there is one operator who has actually now double the frequencies and double the channels, even with 4G. And mysteriously they found a way, which is completely out of comment, that they are allowed to make this 4G allocation 5G without even paying or aligning it technically. So they are now in a position that they bought 5G bands, but also can use their old bands also in the 5G situation. At the end, the market is the biggest loser of this, because the services, the pricing went up, service quality went down, I don't know, internet included in your package was actually lowered, which was a very not compatible example on what we saw in the past for other technologies like FTTH, like building together infrastructure and copper access to things. So it's an interesting situation how somehow the regulator forgot its purpose, and although on your introductory presentation we saw that generally they developed independent and good capacity, sometimes this is lost, mainly because probably human capacity was lost in this regulator, and then it's difficult to continue from there. And now I will put my hat and inform you that there is a question from online, and I will ask our colleague from RIPE to put it into the queue.
So we have a question from Zoran Perovic. I apologize if I do spell incorrectly. Did the situation change for the better, and what each panelist think should have been done better? And this is the question for all. Thank you.
Is the question clear to everybody? Christian, do you want to?
The situation is becoming better? No, it's not. As I said, dropping in 20 years from 8,000 operators to 500 is not a good sign. And in my own opinion, this will continue. People, when they are in a good situation, and I mean by this, I will state it, when there will be only 3 operators and they will feel comfortable, they will do what all of us are doing when we are feeling comfortable, meaning nothing, no evolution. The evolution is coming when you have a healthy competition. And the competition now in Romania, in my opinion, is unhealthy because unfair treatment. Thank you.
I have it. To say something about future in Croatia or in the EU level, because we can separate North Europe and South Europe. Yeah, when we're talking about some connectivity, we expecting better situation, because we expect that some EU funds and 5G rollout, so we expect that we have better coverage, better connectivity. Regarding services, I think we are thinking about the customer's point of view. The most people, consumers want to have services, so somebody will survive. Content is services is the killer applications, so everybody needs more than 30 megabytes. We are talking about some gigabyte society to the end of the decade. That is something not so realistic, but more than 100 megabits is very realistic for each end user, so we are looking in that directions. And I hope regulatory offices and NRAs will be better, No bureaucracy. We didn't notice big complaints regarding bureaucracy in Croatia, so I'm not aware about that situation because everything is online services regarding all some notifications and data for us. It's just few clicks on the mouse. That's all.
I do have a follow-up question. Croatia is part of the EU, but do you also, as an agency, as authority, coordinate with other agencies in the region? Do you have that institutional cooperation?
The usual practice is BEREC working groups, so each country participates in BEREC, and we are trying through that groups have common position, harmonized position, but sometimes it's so difficult because we have different national situations. We notice today in Romania and Bulgaria, but some common principles have to be here. For example, I don't know, currently we are working on a common position regarding this debate about fair distributions on the EU level, so I think BEREC will come with a unique opinion regarding this European Commission debate, so I think maybe it will be much better in the future, what we can do else,
I was especially curious because we are seeing the same companies and the same players in the many countries of the region. And I was just curious from their own perspective, if you do operate in 5 different countries, is the regulation consistent? And how do you actually, does it make it easier or more difficult to have such a structure?
We don't have daily cooperation with some NRAs in other countries. Just I mentioned we have cooperation through this working group in BEREC, but we are open for each, I don't know, questions, issues from another countries. For example, when we're working on some important issue for the Croatia. For example, last year we have analysis regarding universal service obligation. We made bilateral meetings with Slovenian NRAs and Austrian NRAs. Sometimes in this, we can say projects, mini projects, each 1 or 2 years in period. But the regulatory frame is clear on the EU level. It's a point in implementation, I can say, because each country have own way of implementation.
I can also add something here.
Yes.
On a European level, just for the sake of clarity, there is an electronic communication code which is one for everybody in the European Union, but the regulation is country-based. The BEREC, which is the the so-called regulator in the European Union, it's not, their decisions are not obligatory at all. They have a consultancy function. That's why the regulators in each country are making their own decisions for good or for bad. In our case, I think it's for bad. This is the situation. And it's not only the communication regulators, as properly noted by my colleague from Croatia. It is the competition authority. The competition protection commissions are very important in this sense. And when they do not do what they're supposed to be doing, it never works. It never happens. I mean, there are the methodology of researching the competitiveness of the market in the European experience and in the global experience is very well developed. So there are no secrets there. We're not going to discover some new KPI that nobody else has discovered in the world, but they have to be applied. The proper market analysis has to be applied. They can. Instead of asking questions how, the Romanian market or the Bulgarian market, the prices are so cheap, so there is enough competition. No, this is not an answer. They could ask the question, how many different and independent offers can a consumer in the village of, or in the city of, whatever city can actually receive? And if it's only one, there is no competition. Or how many new providers of different and independent services have appeared last year? That would be a much stronger indication of the competitiveness of the market compared to some of the measures that they are currently using. And as I said, all of these things are there. They just have to use them. And what my colleague from Romania complained about the bureaucracy. This is usually, we have the same problem here in Bulgaria. This is usually an indication of a political unwillingness and a political decision on a high level to support the big operators. It's sometimes very clear that they even don't hide it. Sometimes they're very open about it. While they could have a specific strategy for the support of small and medium-sized operators, like when they are the European Commission is having like those financing programs. They have special financing for large companies, and they have special financing for medium companies. They have special financing for small companies. They don't just say, okay, this is the money, whoever is the best, let's get it. Well, obviously, one company is going to get the whole thing. And this is lacking. This is lacking in all of the countries that I know around here. There is no focus on the medium and the small and medium-sized business, and the small and medium-sized business is the core of any economy. It's not the biggest operator. This is a very frequent fallacy. It's a misunderstanding.
And I would like to hear from our panel, because we are nearing the end. Oh, yes. So first, before that, we do have at least one question from the audience, so we will take that now.
Thank you. It's rather more like a comment. I'm from Romania, Florin Dragomir from ANCOM, from the regulator also. Perhaps just to share a bit of my views to complete the picture, at least for Romania. So we have big operators, we have small operators, we have more than 600 operators on the market right now. Yeah, it decreased, but we have more than Germany, we have more than France, we have more than Netherlands, and so on. In terms of, we have, as a regulator, you have several important goals. One of them is the price and the quality of the service for the end user. And right. In this very sense, we should also, sorry, we should also take note that the prices for broadband communication services and the quality of the networks in this region, actually, Romania, Bulgaria, Serbia, are quite good. We are on the top list in Europe or even in the world. For the level of competition, yes, at some point there could be differences if you look at city level, if you look at some regional level, but let's remember, all of us, that we are applying the same EU rules in all EU member states, and there are also rules regarding the market analysis that we all apply, and this is how the situation is interpreted. Regarding problems related to some sort of bureaucracy, I should perhaps we should take note of the fact that the framework that we are applying, the electronic communications common framework at European level, tries to put very low barriers and sometimes actually makes also the regulator life quite difficult, in the sense that we have to ask again and again, because what you declare to us are perceived based on this code as intentions, not something that you have done already. You can start doing something more even without informing the regulator. This is these are the norms in the EU, and these are the norms that are implemented in all 27 countries. So, yeah, sometimes we have to ask again all 600 operators, not 20, some dozens like in Germany or in France, about services and networks. But this is how the European framework works, actually.
Can I say something? Sure.
Okay, no, I can stop here, and I think the colleague from Bulgaria has some comments.
Yeah, let me also jump in after Neven.
Thank you very much. I really appreciate your participation here. I didn't get your name, but you will tell me later, from the regulator in Romania. You are absolutely right. There are a lot of positive things that we can be proud of. And the developments in the past few years is not one of them. And when you compare, I will use something else, because the number of the suppliers is not the best way to compare. There is something that is called the Digital Economy and Society Index in the European Union, the so-called DESI index. This is a comprehensive summary of indicators that show how each country is comparing to the others in the development of their digital economy, digital transformation, digital economy, how the population is using services, blah blah. And this is one of the best indicators of how the results of our industry is helping society. It's one of the best. And guess what? Looking at the latest DESI index, society index, Romania is on the third, starting from the back, and Bulgaria is the first, starting from the back. So how could we, being both countries in the top 5 in the world, just some years ago, ended up to be the last 3 in Europe? It's probably, there is some reason for that.
Yes, there are. And actually you are comparing two different things. If you look specifically in the DESI report, only on the metrics related to connectivity, you'll see that both Bulgaria and Romania are in the top class. What drags down both countries are the digitalization aspects. the alphabetization for the information technology usage of the people, and things like this. Unfortunately, this is where we, both our countries at least, but probably others, should double down the efforts to catch up with the rest of the Europe.
I agree. Thank you very much.
Thank you.
Can I answer Zoran's question?
Sorry?
Can I answer Zoran's question?
Yes, of course.
Yeah, I'm sure that he would tease me if I didn't provide my opinion on this. So generally speaking, things are improving. I mean, statistics are going up, the usage is going up, the traffic is going up, coverage is getting better, investments are implementing. We have a lot of fiber now. We didn't have that a couple of years back, and so looking in a wider context, things are not that bad, and the situation is of course much worse in some other parts of the world. But on the other hand, the market is still concentrated in a lot of segments, and competition and user choice are often limited in practice. And alternative operators keep on, repeating the same complaints. So I guess, that, I mean, I don't have the hard facts because I don't work at the regulator, but if they keep on, repeating the same complaints, it tells me that, not many things are changing. So, what could have been done better? I mean, some things on my wish list, is probably not realistic, but, one thing could be the privatization of the national incumbent. It would benefit both the operator, we're providing the operator with the ability to make sound business decisions and choices regardless of, let's say, non-market influences. And it would make it easier on the regulator as well to enforce the law. Of course, being more agile with legislation. We just cannot afford to not change our legislation in a decade. So, I mean, it doesn't make sense. If you take a look at the legislation in the universal service, you will find there dimensions of the dial-up. I mean, it doesn't make sense. A really important thing is not forgetting about building and retaining capacities within the regulator and the line ministry. You just cannot afford to lose people and have people, leave the regulator or the ministry, because this makes a difference between being able to conduct some market research or change the legislation or execute, for instance, rural broadband project from the initial idea to 100% deployment in 5 to 7 years or 15 to 17 years. It really makes a difference if you have capacities, and this is often overlooked in Serbia in particular. And I would say much more focus on the end user experience by the regulators and the government in general, meaning also more effective consumer protection. And as I said in my opening intervention, these are just some things that could have been better, and there's no single silver bullet to just do one thing and things will structurally change. I mean, it's the efforts of many players done over many years that can move the dial in the desired direction. So it's really a mix, but this was some things on my top list, so to speak.
And thank you. And we do have another question from the audience.
Yes, for the record, my name is Desiree Milosevic. I'm one of the co-chairs of the RIPE community working group, and the cooperation working group is a place for network operators, but also for regulators and governments to come together and to discuss future impact of new regulation. So with that, it strikes me that here we're talking about the future, about the diversity of the networks, the connections that are missing in rural areas, and the RIPE community has to make the response to this open consultation that EU is now looking to get answers. I think Ms. Gaspar mentioned the future debate about the future of EU infrastructure, and I think that includes all of us. So I would urge all our members to actually send their response to the questionnaire that you can find on EU's webpage, and the cooperation working group itself has taken upon ourselves a task to form a small task of volunteers who will be responding to some of these, and we'll be happy to share some of our inputs that this small task team is working on. We cannot, because we're not a telco, or many operators are not a telco, so they cannot actually answer probably 2/3 of this questionnaire, as it's asking for deep data. But I think we're all concerned about the future of the network, and we should use this opportunity. The deadline is 19th of May. To really send our messages and amplify it, because they're welcome to the countries outside of the EU region as well. Thank you.
Thank you, Des. Another question from the audience.
Hi, Brian Reiter from 5x9 Networks in Croatia. So when we're talking about the rural connectivity, basically we have an answer. It's controversial at best, so it's Starlink, basically. So not just Starlink, but OneWeb, Blue Origin, companies that are said that will do the stuff that is Starlink doing today. So my question is, do you think that Starlink is a welcome addition to the competition, or it will squeeze the smaller operators still? And the second question is, for regulators, how difficult it is to manage and to regulate such big global companies who don't operate on landline or mobile, but out in space? Thank you.
What was the first questions, please?
Is Starlink a welcome competition, or you think it will squeeze the smaller operators even still?
Welcome competition. Yes, normally every competition is welcome. So it's depend, from situation to situation. But we can say that each competition is more than welcome.
But do you think it will have an effect? So the smaller operators, we're talking about the consolidation of the market, how there are less and less of these smaller operators. Do you think that maybe Starlink or OneWeb or whoever will be another of these major operators who will bring down the margins for the smaller operators? So we see a lot of smaller operators operating in the rural environments, so even with the EU funding and everything, but Starlink is coming out of the blue or out to the space, and bringing high speeds, low latency, and basically being another big player in the market.
I think the existing regulation on the high level, on the symmetric regulation and the wholesale products is sufficient. So on the retail markets is we can say, because we don't have regulation on retail markets, we have competition itself. So if we have some distortion on the retail markets, in that situation we get competition agencies. So regulators have to put in force some appropriate, fair, proportional, symmetric regulation and wholesale regulation.
Thank you.
And the second question? Do you remember the second question? How difficult is your job regulating, right?
Yeah, how
How
difficult
is
is to
difficult to regulate? There isn't, differentiation, big or small operator. There are rules, and they have to fulfill that rules. If not, we have, we can say, good legal frame, because we can put very big penalties, and that's the answer for the good, I can say, competition. Only if you have good legal act, legal frame for the big penalties.
Okay, thank you.
Maybe I can add a few more things. You mentioned the small local operators. It's usually when there is a small local operator, the cost of providing the service, locally, is going to be much cheaper usually than what you pay for Starlink, both for the initial installation and for the monthly cost. So, to compete at the local level with the local ISPs and get them out of the job, the price of Starlink is going to have to, drop, I would say dramatically, but, maybe not dramatically, but significantly to what is now. But this service has a value, in places where you actually don't have any local operators, in the remote areas, and also for some nomadic purposes. So if I was, the regulator, I would really welcome this means of providing services and covering areas in which you just don't have any option.
Thank you. And before we move to the closing round, I would, yes, we have time for another question.
Hello. I don't have a question, actually. I want to give you some information in order
Could you please introduce yourself?
My name is Ciprian Agoste. I'm from Romania. And I would like to add some data for you to have an even better image for the market in Romania. So there are about 500 or 600 companies with registered as ISPs, but the first four companies have a market share of 95% of the market, and the first one is more than 70%. So this is a competition in Romania. Thank you.
First one, more than 70%, that's what you said?
Yes.
Can you confirm that?
Yes, I can confirm, and I am very curious when there will be only 4 operators. All those hundreds of employees of the regulator, what will they do with 4 operators? Thank you.
Do you want to comment on that?
No, I'm talking about our regulator.
Okay.
Should I respond?
Please.
Yeah, looks like it's a Romanian affair, this discussion. Somehow.
Latin blood.
Yeah. What can I say? Well, first of all, perhaps we should learn who is this famous 70% operator. Actually, it was a newcomer when the liberalization came. It's not the incumbent. It's not any of the big operators. It's not Orange, it's not Telecom, it's not Vodafone. It's a Romanian company who started from scratch, from zero, in 2003, and now holds 70% and is also providing services in other countries in Europe. He's recently expanding his foothold in Spain and Italy. So, how does he do it? Well, he was a very big company, a very small company like you, like the companies in Interlan and that are presented here in this meeting, and just was very aggressive on the market, so to speak. Saw his best interests and profited on the liberalization of the market. Obviously, at the beginning, had a hard time with the incumbent, but he managed to solve this problem. So again, my question would be, how come in this situation we still have one of the lowest prices on the market for internet service? That's a very strong point in front of the regulator. I mean, you have to admit this. Thank you.
You want to respond?
Yeah. I will just start this, and what I would like is not a debate, but it would be very interesting to have a later meeting for bigger details. So, from what I know, and I may be wrong, the market in the 90s was quite the opposite as the one that it is today. The micro and mini operators had more than 50% of share of the market. This was the times where big speeds and small prices started. I remember, because I was there, I was operating, I was with cables, so I was directly involved in this. The big operators didn't have almost any chance, so they had to adapt by lowering prices and giving more and more bandwidth to the end users. And then one of the things that happened, they started to buy a little bit small operators, because it is true that it is very hard to keep up with giving everything for nothing. Things changed. Not everybody has the same goal in life. Like, though that big operator wanted to be a big operator, but there are several hundred others that just want a living for them, their families, and the families of their employees. They are not going into space, or not even in the next county. I'm not talking of the next country. So we have to take this also into considerations when we are comparing companies. Some like the big fortunes, some don't. And apparently one of those who liked that big company succeeded in becoming the leading operator in Romania. Thank you.
No follow-up questions? I would use the opportunity I would like to hear from other people in the audience, from other parts of the SE region. Maybe if we have somebody from Slovenia, or Montenegro, Albania, or even people who are watching us online. I would like to hear from you to get your contribution to the discussion, or maybe you have some questions for the panelists. Is there anyone here that would like to say something? Yes?
Okay, could I just go to my laptop to show some results, because about this index is very, important. So I'm Paula Miušković from Montenegro, it's a regulatory agency. So regarding this DES index, which all we can compare, it's very easy. So when you look Montenegro, we look the broadband connectivity. So Montenegro is 10.4. The average for Europe is 15. For the Western Balkan country, it's 7.5, so we are the highest in the broadband connectivity. And when you take how you calculate the broadband connectivity, it's a result from 2022. It's calculated on the data for 2021. In 21, we didn't have like a 5G. So because for 5G, for the spectrum and populated areas coverage, we get a 0. If we add this, probably we will come very close to the European average. So right now, we had the 5G, it's covered about 75% of the population, and we also did the auction in 5G. So we sell the Spectre 700 megahertz and 3.6 megahertz. We have like a 3 main mobile operators. The Spectre evenly divide. So in all this area, we have almost always increased the number of the traffic is increased, the number of customers increased. We have, let's say, a good result. So also we are good in this other part of the index, in the DESI indexes, except the part of the digital public services. This is where we are low. So, so let's say if you go with the incumbent, also I have this data because of this. I took the laptop even in the fixed, let's say, network. In the fixed telephony, that usually you expect to be the incumbent, the dominant. It's 53%. The second one is 37%. So the market is divided. We don't have, let's say, we have just not too many operators. We have like a fixed operator from the fixed telephony and 3 from the mobile telephony, and we have 12 internet service provider, but you can say it's it's 4 major one, and also we have the pretty good investment. Investments range from 20 to 50% of the revenue income of the market, and we usually the income on the market it's about 230 million. So I think we are doing good. So this is
So
the game.
your general assessment is that Montenegro does have
Yes, and just now I forget,
competition.
we have like about 14% of the household, it's not in area of the broadband, and we divide this in the white, gray, and the black areas, and we need about 110 million to cover this. So, and also we are now in the kind of the project. Right now we are making the tender documentation for the investment to cover this 14%. So just 14, just to be clear. Okay, thank you.
Thank you. Anyone else? Slovenia, Albania, Greece. Okay, thank you all. And so I think we're going to move to the closing round now. And I would just like to hear from all the panelists, looking ahead, how do you see the future evolution of the market? And how do you see the role of both the regulator and the government in this process?
Well, I hope, what I hope is to have a dialogue, a real one, not based on, I mean, even regulations can be understood differently. They do in different countries, so people can, in fact, change opinions while respecting the law. I hope things will change for the better. Thank you.
I hope we will have faster reaction from regulatory offices, competition, telecom, ICT may be regulatory office in the near future, because we are talking about convergence and it's a big challenge for everybody to make fair, proportional and timely regulation, digital services and electronic communication services. Because we have to face it in the short time, and if we are talking about long term, about some gigabyte society, I just want to happen that each customer, each citizen have minimum 100 megabits in rural area, and that's the most important for the public.
By 2030.
Yeah, 2030. Okay. That's all for me.
Neven, maybe you want to go next?
I cannot see the future, so What I'm sure about is what I can do and what we can do. And I think that we should be very dedicated in, and very smart in working together, exchanging information and experiences, and working with our corresponding regulators and governments to make sure that the focus is always on the consumer, it's always on the competition, because this is the only force that can help the life of ordinary people.
Thank you. Slobodan?
Well, I've said it a couple of times during this session, but generally speaking, being more agile in legislation, building and retaining capacities within the regulator and the line ministries, focusing definitely more on users, and this means building capabilities for gathering data from multiple sources by the regulators, and of course being more effective in application of legislation, in enforcement of legislation. So, I mean, there is no one thing that is the most important. You really need to apply, multiple things over many years and work on different fronts to, see a tangible change. So, so that would be, my final words for this session.
Thank you, and thank you all. Big thank you to the panelists and everybody who stuck around until the end, and for the people who followed online as well. And I would say, just listening to this conversation, my big takeaway is that we definitely need to talk to each other way more than we did so far, on many different levels. And the opportunity to do that is at the SE meeting. So please join us again next year. And we're looking for a host, so host country. So please, if you want to to provide a platform and to provide a space for us to continue having these important conversations, yes, get in touch with us, and you can be our next partner. Thank you.